the 3 days. Why you were not recording from the beginning?
I'm very, very sorry. I didn't remember, like, so it was out of my mind, but I think we can, if you get a chance, please join us on the last day. It will be on Saturday. So if you'll be available, please, we will appreciate having you for closing.
Okay, we will see. I can't commit, but I wish you all the best. If I'm able to attend, I will.
Yeah.
I just want to emphasize on the areas that I've mentioned. Let us make sure that we get the stakeholders right in the drawing board when we are designing these ideas, we're designing the solutions to enhance adoption of what we are bringing forth. So I wish you all the best, Zephania, and good luck in this. For the 3 days, I know the students are going to have a very big outcome of this, and yes, we advance it as that. Thank you.
Thank you so much. Thank you so much, Dr. Devota and the Nelson Mandela team. So now I'm going to welcome Anna Grace from Tanzania AI Lab to tell a bit about what is it, and because they are one of the collaborators making this happen. So Grace, you're welcome.
Okay, so my name is Anna Grace from Tanzania AI Community. I am the brand and social media lead, so I'm here as a representative from the Tanzania AI community. It's really nice to be here with you today. And the Tanzania AI community is just a community that empowers those who are passionate with artificial intelligence in terms of skills, networks, resources. If you're passionate about AI, if you're passionate about building, if you're passionate about machine learning, then this is the community for you. We have our social media pages, Instagram, Facebook, LinkedIn, Twitter, X. Feel free to follow us so that you can be updated on everything that goes on within the community. And if you go to our website, www.ai.org.tz, you can find a Google form. There is a button written join the community. So if you click that, it will take you to a Google form where you can fill to be a part of the community. And at the end of it, there is a link to a Telegram group that we also share some constant updates. So with regards to today's event, as you have heard, we are going to be hosting the Deep Learning in DabaX locally here in Tanzania in collaboration with the Camel Labs, specifically the Emai Conference. And we are going to be giving training on topics related to AI and machine learning. So I hope you're all excited. I hope you're all here to learn, to network, to partner, and hopefully this event will be something that is worth for you guys to be here for. So thank you very much. I hope to connect with you throughout the days. Thank you.
Yes, so there is certain issue about the AC. I don't know, but we have communicated that we are going to adjust it a bit. Yeah, so next I'm going to call a representative from the National Museum and House of Culture to tell a bit about, I know maybe we have some anticipation of what is it, but we are going to hear from her. And again, wao ndo wametuhosti hapa, kwa hiyo tuwapongeze na tumkaribishe. Yeah.
Hello, everyone. My name is Mwamvita Solo. I'm an ICT officer of the National Museum of Tanzania. Lakini, I'm here to represent the Director General of National Museum. So I have your greetings here. I'm going to read as it is because they've just given me. So, dear organizer of this workshop, dear participants, ladies and gentlemen, on behalf of the National Museum of Tanzania and on my own behalf, I would like to take this opportunity to welcome you all to the National Museum of Tanzania. Thank you for choosing to work with the National Museum, which is a scientific, educational, and cultural institution entrusted with to acquire, research, document, preserve, and display all material related to Tanzania's cultural and natural heritage. In preservation of natural and cultural heritage, the National Museum of Tanzania disseminates such knowledge to public through cultural and educational programs, exhibition, publication, print, and electronic media. I also take this opportunity to congratulate you for this important workshop on enhancing mind artificial intelligence, which is the theme, innovation with intelligence, shaping the future, which is in the line with the National Museum of Tanzania, functions and responsibility to the young generation. The National Museum of Tanzania has different programs and events that involves different stakeholders. One of it is the Museum University Hub, which deals with the university students who are taking their studies in the fields that relate to the museum's core functions. The aim was to open up and introduce the opportunity available for them. This year, we have opened a new avenue on the stream of technology and scientific perspective, which has been not included before. The theme of this conference states that innovating with intelligence, shaping the future. This underlines the museum core functions on shaping the future through the national and the cultural heritage in application of artificial intelligence innovation. Being that case, there is no way the museum products and services will stay away from the line and affects the technological advancement like the one we are here for today. The museum products and services have a lot of scientific opportunities. To mention few are in areas of research, publications, digital exhibitions, animations, storytelling, and events, without forgetting the world of tourism industry. Artificial intelligence is one of the modern technological opportunities that will introduce our tangible and intangible heritage to the world due to the diversification and uniqueness. The government is encouraging the young generation to invest their knowledge of new science for the better of our community by embedding the new technological inventions to promote and use them as economical products. It's my hope that this workshop will help the participants to shape their future as we, National Museum of Tanzania, are looking forward to more events of this kind and the introduction of new projects that will service the main function of the museum. Thank you.
Thank you so much.
Karibuni sana.
Yeah. So we can visit social medias, like the social media pages of the National Museum. So we can be getting different updates on the activities and different areas where we can explore and learn and actually know our history.
Yeah. You have to know your history. Yeah, where you're coming from.
Yeah, that's very important.
Also, you can tag us, please tag us. We have our My colleague will
Yeah, yeah, yeah.
tell you our
Then the-
Instagrams,
Yeah.
social media pages. Please
Yeah.
tag us
Thank
when
you so
we
much.
post your.
Thank you so much. I think we can get them now, right? Yes. We can just we can stand up and tell us. Oh, they're here.
Yeah, please.
Yeah. Yeah. So it's Facebook Makumbusho ya Taifa NMT, Instagram Makumbusho ya Taifa, like imeunganishwa ila inaanza na M kubwa. Or you can visit the website www.nmt.go.tz. Nadhani from there kule unaweza ukapata pia the social media accounts. So thank you so much for that introduction about the National Museum. So we are behind time actually. Kuna session moja hatujaifanya that we need to get breakfast, then we'll be here to continue.
I'll just a few minutes to take that.
Yeah, so we are having a break, like a breakfast. So we'll be back, I think, in 20 to 30 minutes. Hello? Can you hear me? Hello? Yeah, so if you can hear me, you can just type.
Yes, we are hearing you.
Ah, okay, thank you so much. Yeah, so yeah. So we are going to the next session, and because we were discussing about AI and its dimensions, so we are going to do that, like to continue with that conversation, but at the same time we're going to be looking on the current state of AI. So that's what we are going to be looking. So I will share here. It's a document here. Okay, let me share screen. Yeah, so I hope people from online, you can get me well. We are going to the next session where we're going to be talking about the current state of artificial intelligence. So, can you hear us, right? Hello?
Yes, we can hear.
Okay, thank you so much. Okay, yeah, so to start this session, the report you are seeing there is the State of AI report of 2018. So why I've shared that, it's because I want us to see like what are the changes. So we are trying to reflect AI, like state of AI in 2018, and then we're going to compare with the state of AI in this year, like 2024. So the like this report is being published by those two people there, Ian and Nathan, and they do it, I think, from 2017. They've been doing that. Like they've been publishing these reports. So if you want to see them online, you can see state of AI. State of .ai. So when you go to state of .ai, I think you're going to see the reports from 2017 to 2024. So and previously, so you can start to note like they focus on research, talent, industry, risks, prediction, and then they have a conclusion. But let's
focus on the four aspects, like the research, talent, industry, politics, those four things. Why? It's because in research is where we get the new breakthroughs of AI, like the new concepts and the new innovations. And then talent is what actually you need talent to come with the breakthroughs in research. So they try to see the demographic of like research or talents in AI. So where are they centralized, or is it like distributed across over the world, or is like there is a lot of talent somewhere and in other countries there's no people either doing AI or doing research in AI. And the third thing is the industry contribution. As we know, in previous years, most of the researchers were coming from academic institutions going to industry. Like academics do research, more theoretical research, and then those researchers are being used by industry people, like to do engineering of their products or like changing them into application, like solving a certain social or community problem. And then the other aspect is politics. Why? Politics matters a lot when it comes to AI specifically. As you can see, Russia, China, and other countries, like they compete, like they have plan. Maybe I want to be a leader in AI by the year 2030. For instance, China, I think, if not Russia, they have that vision, like they want to be dominant in the space of AI. So it's important to look on geopolitics and how they affect the development of AI, but also the applications. So they have highlighted the research, talent, industry, politics, where they look on public opinion on AI, economic implication, and emerging geopolitics of AI. So this was 2018, and yeah, so these are the authors. You can just learn about them and what they're doing. So these are the definitions back then. So you can, if you want to visualize what has changed, you can start here, like what they defined in 2018 and what they've defined this year, like the terms. So as you can see, we have artificial intelligence, machine learning, reinforcement learning, deep learning, which are the concepts actually we're going to explore them tomorrow, because tomorrow is more of a workshop session. And other definitions: algorithm, model, supervised learning, unsupervised learning, transfer learning, good old-fashioned AI, where you see like the symbolic AI. So just to share a bit on symbolic AI. So just a concept of AI where it's like we process symbols and we use logic into creating AI systems. So there are some researchers who argue like the current state of AI, which is driven by artificial neural networks, needs symbolic AI to actually be able to do some of the things like reasoning or planning and other similar cognitive abilities. So let's leave that. So first section is research and technical breakthroughs. This was 2018. So you can see they were talking about transfer learning. So back then, 2018, transfer learning was like a very a new concept, specifically in natural language processing. So what is transfer learning? I'm going to share a bit. It's just a knowledge transfer. So we train an AI system on a certain program, and then we can transfer that knowledge to another AI system with minimum data. For instance, let me give you a big picture. We take images, like it's just a little scenario. Let me share it as it is. So there is a data set on the internet called ImageNet. So ImageNet, you can check it. It's like a bunch of images, like millions of images with different categories. Like they have different objects. It's like 1,000 objects. So when you want to do transfer learning, what they do, they take those images, like millions of images, which have almost 1,000 categories or objects, like a car, boat, anything like 1,000 objects. And then they train an AI system to be able to detect or to recognize those objects. Like when I give it a picture of, let's say, a chair, it's going to tell me this is a chair. Maybe I give it another image, maybe of a table, it's going to tell me this is a table. So 1,000 objects. And then, because to train an AI system is very costful, so what is being done is, like, we take the trained AI system, which has been trained on understanding images. Then if you want to solve an image problem, so now we want, let's say, to solve let's say cancer diagnosis using X-ray images. So what we're going to do, we're going to take that model that has been trained on millions of images, and then we train it on other image, like an image based on our problem. Let's say we have, let's say 500 images of X-ray chest image. Then we use them to train that specific AI system to be able to do diagnosis, like to tell if this is cancer or not cancer. So that's the concept of transfer learning. Like, you are transferring knowledge of that system to another area where you want to solve a certain specific problem. So that was what's happening. Oh, I don't know if I'm recording too. Yeah, it's recording. So that was it was a deal back then, 2018, and it was very possible with images, but it was somehow difficult with language. Like, when you are trying to solve a language problem, it was very difficult to do that kind of technique, like to transfer knowledge. Maybe, as you can see currently, you can train a neural network on internet data, and then you can use it to solve another problem on your own context. That's transfer learning. So back then it was possible with images, but it was a bit difficult with language because of the techniques or technologies which are being used at that time in solving language problems, which we're going to explore them tomorrow on the session. It's named Autoregressive Language Models. So you're going to learn all the language techniques, which are like how they evolved from those which were not supportive to transfer learning to the current techniques which are being used to solve these, like to do transfer learning. So this was one of the research breakthrough, I can say. So they are trying to tell us about the transfer learning. So you have a pre-trained model, and then you use it on another specific case. That's the concept. Like, the model which has been trained on the large data set, we refer it as pre-trained model, and then we can use it to solve another specific problem. So you can take you can take a look on this report. So I won't be reading everything. I'm just trying to show you what was the innovation back in 2018 in AI and what is the current innovation. So they also coming to talk about the AI hardware. As I said before, AI is very costful to train. Why? It's because it needs a lot of computation power. So they also try to check on computation power needed. So as you can see, like the performance of GPU around that time. So there was like an increment from the year 2013 to 2015 on the available computational resources with their ability to process or to train faster. So yeah, that's it. So let's find something else here.
So they are still exploring AI hardware. Yeah, so another issue was the issue of object detection. So traditional computer vision described visual scenes by learning to detect objects. So this was also another thing, object detection. So you have an image and then you can detect the objects on the image. So as you can see, it has say there is a boat there in the picture, a person, a dining table. Yeah, that was also a thing, like the semantic segmentation of objects. Yeah, so they are trying to, they're trying to say something like detecting objects in image is not enough to produce a scene. Let me do this. Yeah, so they are trying to explain what is happening, but just take the object detection concept. Okay. Let's find something else here. Yeah, so they are talking about reinforcement learning and how they're being trained on behaviors. So I want to talk about that. Yeah, so back then, OpenAI was building things actually, but it was more in gaming. So before they built what we know currently, ChatGPT, they were trying actually to navigate through different paths. So they were building like AI systems for gaming. Like the Dota 2 was a gaming AI system or AI agent. So there is a lot here on the research part. Yeah. So the second section is talent. So you can see there's a distribution of talent back then. As you can see, most of the AI talents are concentrated at the West. And as you can see in Africa, I don't know who these countries, it's more of South Africa in the northern part of Africa. Yeah, that's what was happening in 2018. So I expect to see the same map maybe on this year's report and see how it looks currently. So this was what was happening. So this was like global AI talent pool heat map. So this was the heat map for the talents in AI. And the numbers are here, so you can find the whole report. Element AI estimate, high level research worldwide. Let me something else. Concentration, America remains the hub for a talent exchange. So you can see America still exchanges talents to other places. Google is widely acknowledged as a leading employer of AI talent, as you can see here. And you can see OpenAI back then. So it was Google, and then you can see most of the AI talents were being employed at Google by that time. And yeah, so these are the research papers which were published at ICML conference. So most of the paper were from Google, then Microsoft, and the others. Okay, so percent of ICML paper with Google or DeepMind the author doubles. So like the number of papers which were coming from Google or DeepMind, a subsidiary of Google, like they doubled from 2017 to 2019. So that was the, let me see if we can allow some people here. Yeah, so that was the talent highlights. Then we go to industry. AI takes the world stage. They're together. Let me see. Top US companies for research and development spending. So as you can see in 2017, the spending in AI research and development, it was Amazon, then Alphabet, the mother of Google actually, then Intel. So these are the companies which were investing much into AI research and development. Yeah, so the other area, let's see. Yeah, so they are trying to explore application too. Yeah, so here's the politics part. Yeah, so this I think this statement is interesting. 18% of Americans indicate that they personally know someone who has lost a job or had their pay or how was reduced as the result of workforce automation. So this was 2018, 8% of people in America actually knew someone who either were replaced or his or her salary were reduced because of AI automation. So now it's 6 years. What percent could it be? Okay. Yeah, so yeah, this was, so let's go to the trend 2024 AI report. How is US labor market actually going? Unemployment rate. Yeah, I think this unemployment rate was decreasing. Despite increase of automation, the US unemployed rate is at 17 years low. Okay, more broadly, how is US labor markets changing? Yeah. So I think we have some highlights now of what happened actually. So this was the James, we were talking about the AlphaGo. So what they're saying here, AI nationalist fear of national AI strategy announced. South Korea announced the expands to existing of AI prime. So like it's more of investment, like countries were investing more into AI. Yeah. Yeah, so these reports actually sometimes they include these predictions. So they put prediction for the next 12 months after they publish their report. So then they put these predictions for the year 2019. So you can check if the predictions were true. Yeah, now let's go to the 2024 report. Yeah, so this was published 10th of October, it's like 1 week ago. So one author changed actually. Yeah, so as you can see, something has happened, like there is an item that has been included in the list of items. As we know, we had research, talent, industry, politics. But can you note something there? So why theft? Let's talk about it. Why do we think they added that? Have something? Yeah, so I'll give you this microphone because I want the online people to hear you.
this is a very novice view. The recent Nobel Peace Prize winner, one of the guys said that he used to work at Google, so one of the concerns was that some of these AI systems, you can give them code to try and regulate them, but sometimes they can decide to quote unquote disobey the code. So that makes it a very risky affair. So worst case scenario would be an AI apocalypse. Now Elon Musk and Bezos, they're making robots. So we don't know how many they're making. But at least maybe not in Africa at the moment. I don't think anyone is making robots here, unless Dina is making some.
So thank you so much, James. Actually, I think you were talking about of Jeff Hinton. So Jeff Hinton actually left his job at Google so that he could be free to talk more of AI safety and how maybe we can regulate how AI behaves. So now we have 5 items. So we have research, industry, but talent is not there, right? So we don't know why they removed talent. Maybe we have a lot of talents now. Yeah, so let's explore again. So the first thing is artificial intelligence, but you can see new other terms: artificial general intelligence, AI agents, AI safety, computer vision, deep learning, like the previous. Then we see another new term, diffusion. And then we see another new term, generative AI. It was existing back then, but it wasn't highlighted in the report. And then we see GPU. We see another term, large language model. And then the new term here is self-supervised learning. Wasn't in the first report, like in the 2018 report, even the transformer. Yeah, so you can see like a very new perspective of like what happened within 6 years. So you can see here model types. We have input output. So it can be text, can be input into model, image, code, software tool, video, music, 3D, robot state or biological modality. And then we have model types. So we have, so this was like the representation. So we have text to text LLM, and then we have text plus image, then it outputs text. Then we have text plus image plus state, robotic state, to produce text. That is multimodal LLM for robotics. And then we have text to code for programmers. I think you're familiar with that. Also, we have text to software tool. And then we have text to image, that's common too. Then we have text to video. I think that's also common. There are some of the tools which we put text and then they produce video. Then we have text to music, and we have image to 3D. We have text to 3D. We have text to biological modality. So like you can just note there is a lot of things which has happened from 2018 to 2024. We didn't have these models which are able to take text and produce something in different
modalities. Okay, let's explore. So the summary is here. Research, Frontier Lab performances converges, but on OpenAI remains its edge following the launch of OpenAI O1 as planning and the reasoning emerge at the measure frontier. So I highlighted about planning and the reasoning. So we can think of it like in more of human perspective, like mostly when we want to do things, we reason about them, and then we can plan some few steps to reach what we want to do. So that's what the current research frontiers are trying to replicate in to the existing AI systems. So we have an AI system, and then we try to make it reason or think of what it is producing. So I don't know if it's actually, I don't know if it works the same with human too. I was trying to think some few days back. As you know, large language models, when they start producing the response, they can't undo what they've given out. So let's say maybe I'm writing a letter to, like, they can't do it and then like, hey, I have made a mistake, let me start again. Which is in human ways, sometimes we can recognize our mistakes while performing an action, and then we can undo and then continue. But with AI, I was trying to think with the current AI models, sometimes when they start to generate, they don't reflect about what they are generating. They just want to complete the task which has been given to them. So the new frontier currently is to make them reason stepwise on what they are doing, and if it's what actually meant by someone who communicated that task to them. Yeah, and then they say US sanctions phrase to stop Chinese virtual LLM rising are community leadable. So I will just highlight a bit. So there is a leaderboard where it tries to evaluate the performances of these large language models. So I think, I don't know if I remember its name. Let me check. I think I'll check its name here and show you. So they've been given points. So you find maybe the current OpenAI model, which is OpenAI O1, maybe it has these points, and then the other models, if you want to see maybe what large language model is currently performing well, you can just raise that leaderboard, and then you have that insights. But so they give also highlights on industry, where NVIDIA remains the most powerful company when it comes to AI hardware. But on the politics part, while global governance effort stall, national and regional AI regulation has continued to advance. As you can see, like in a few months ago, is it the African Union also published like was it a strategy? I don't remember, a strategy or something, regulatory thing about AI for Africa. So I tried to check it, but also we have the safety part. Yeah, so let's try to check some issues. Yeah, so as I said, they usually put predictions. So they are trying to review their prediction, like the 2023 prediction, to see what happened. So as you can see here, one of the, I don't know if they are readable, but I try to read here. A hold grade production makes use of generative AI for visual effects. So they predicted like Hollywood will be using more of generative AI to produce visual effects, and that is yes. They said that it's been happening. And the second prediction was a generative AI media company is investigated for misuse during in the US 2024 US election Not yet. They are waiting for their election actually. Self-improving AI agents crash state of the art in a complex environment, game science. So they say that is didn't happen. So there is those the validation of the predictions. So let's start with the research part. So now the research part is having different things. So from the 2018 report, we saw like the issues such as transfer learning and other issues, but here they are talking about the OpenAI models, which are leading actually in the current best models compared to other models, either the Cloud 3.5 Sonnet or Gemini, also compared to Grok 2. Yeah, what is, yeah, so there is details here. I will share the reports so you can check on the website. Yeah, let me share something. As I said before, like one of the things which is currently being researched on is the ability to reason and plan. So there are different techniques which are being used to trigger these large language models to have ability to reason. And one of them is that COT, like a chain of thought. So chain of thought is just a technique where you like, it's like you either you break or you trigger. For instance, when I write a prompt like I have this mathematical, I'm telling you like, here's my mathematical problem, it says ABCD, and then at the end, maybe I might tell a model like, think stepwise. So like I'm triggering it to follow like steps when it is trying to solve my problem. So that's a very, very simple concept of a chain of thought. So it's being believed that in the current OpenAI model, they used some combination of chain of thought and reinforcement learning actually to improve the reasoning ability of their models. Yeah, so another thing is Llama 3. So what is Llama 3? That's a large language model, an open source large language model produced by Meta. When you talk of OpenAI O1 or the GPT series, all of them, except for GPT-2, I think, 21, others are just closed source or proprietary models. Like they cannot be accessible to the community. Like the community can't use them to either do research on top of those models, or maybe use them for some specific applications. It's like owned by those specific companies. Specifically, I'm talking about OpenAI. But then Meta came with this initiative of creating large language models and then open sourcing them to the community so that they can use them to solve their problems, either locally or doing research. And currently, Llama 3 is the leading open source model. So there are other communities actually, but the leading one is Meta 3. So in the research part, they're highlighting how Llama models has improved from the first version. I think it was released the area last year. I think if it wasn't in February, and then they released the Llama 2, and then they released Llama 3. And now we have Llama 3.2, which is having more, like it's more capable compared to the previous version. So I want to go into technical details because we have a session tomorrow on exploring, if you can see there, exploring open source large language models. So it will cover some of the concepts about Llama 3 and the other open source large language models. Yeah, so the point is
you can see in 6 years, the capabilities of AI system has increased, like exponentially increased from where people were like from the time where we were not able to do reinforcement, like to do transfer learning on language-based model, to the point where the current state of AI is language driven. So like it's a very big shift, because by 2018, most of the AI applications or AI things were more concentrated into the vision space. Most of the people are doing computer vision things, because research in language, people are doing actually research in language, but where, like when you compare the ratio, the proportion of people who were into language and who were into computer vision, it was actually unbalanced. But the current state of AI is mostly language driven, so that's a shift. Though there is also a combination, like the technique which brought this shift, or the technology that brought this shift, that is transformer, has been also being applied to vision program. So I think we talk about them, like the vision transformers and how they're being used to improve the computer vision space, but also how the current model are able to combine or to unify the modalities, like to bring together image, language, vision, video, and other modalities. Yeah, so let's see something else. Yeah, so as I shared on the 2018 report, there was something highlighted, symbolic AI, which they called it like old-fashioned. So let me come back here. Okay. Yeah, so when you see this, like they have said, where that statement? Yeah, so you see here, like good old-fashioned AI, and then they mentioned something symbolic AI. So this was being seen as an old-fashioned kind of AI. But when you come to this year's report, you cannot, like they've said, a neuro symbolic system making a comeback. Like they are now coming into play, or like they're being combined. Like we take the symbolic AI and then we combine with the AI that is artificial neural networks based, to try to improve the current state of artificial intelligence. So we can have more time to explore there. Yeah, so there is another thing here which I think is very important to share. Most of these models which are being produced, specifically from the year around 2022, 2021, 2022, they were very large, that most of the people were not able even either to build some applications on top of those models, because they are very large. And people started to do research again to see how they can reduce the size of those models, so that they can be used into other applications, or they can be embedded into the edge devices, for instance, mobile phones. So it was last year, if I remember well, Microsoft came up with their model, the five models, 5 series. So what they did, it was because as for the first generation of large language models, it was based on the large, like the large corpus of text from the internet, like millions of text from the internet, which were trained on a huge amount of computation, and then it produced a model that was very large and large in terms of number of parameters, or like the number of parameters. You can think of parameters that the knowledge stores. Like to give you a perspective of parameters, it's like maybe you have like, trying to think of a very simple example. So you have, let's say, the either bakuli or the hotspots, so where you store your things, and then when you are training an AI system, it's actually gain knowledge by installing it into its parameters. So it was known that by having large amount of data and a large amount of compute, you're going to have a very good performing model, like a model that is very capable. So what they were trying to do is to increase the number of, increase the data in token wise. So they usually they usually quantify amount of data in token wise. So token is just like, to give you a brief understanding of what token is. If you have a sentence like I'm going outside, and then you can break that sentence into words. Let's say I'm going outside. So I use that strategy of splitting them in words. So then you're going to get, like, you have 3 tokens. I'm going outside. So that's it. Oh, I'm going outside. That's like, it's 3 words. So you can say I'm having 3 tokens. So that's a simple way to quantify the text. So that's just the one strategy. But there is different other strategies that are being used, which I'm not going to talk about them because I don't want this to go more technical. But so when you have very large amount of text, and then you have very huge computation or power computers, you have the guarantee that your model is going to perform well. But the drawback was the model produced out as an output of having large number of text and having that computation. It was a very large model. That's why they are being called the large language models, because they are very large, and they're very large in terms of number of parameters or number of knowledge stores. So Microsoft tried to explore another direction where they envisioned to create small models, like small language models, and they started to come with the first version of 5. So what they did, it wasn't like taking the whole, like the corpus of text from the internet or describe the internet. They tried to concentrate more on quality of what you're using. Like when you take everything on the internet, it's like not everything is having that quality you need. So what they did, they tried to concentrate on books, like the quality data. So they took some number of books which are very like they are well known either in a certain area. So they collected books which they believe they are quality, and then they used them to train their model. So they created a model which was having 3.8 B parameters, like 3.8 billion parameter. When you try to think, I don't know the current, because most of the researches now are not being open source, like you can't know the they don't give more details on what they're building or on what they used it to build. So, but for the last information I have is it's been said like GPT-4 was having 1.4 trillion parameters. So you can compare 1.4 trillion and 3.8 billion. Like it's very there is a very huge gap in between. So that's the direction where Microsoft started again to move, like to create small models. And then most of the models actually currently, when they produce a model, they give it in different versions, like a small one and the large one. For instance, for Llama 3, the large one is having, I don't know if it is 403, 402 B parameters. I don't remember well, I think I have to check that. So this was another direction again, like to create small language models so that they can be used into the edge devices like smartphones. As you can see, currently, most of the smartphones, for instance, when I just go even to a text, like a messaging application, I see there is a Gemini there where you can use it to compose your message. So they've been made, like they are currently small so that they can also being used into the edge devices. So let's see if we have another thing. Yeah, so strong result in quantization point on the on device future. So the quantization is just is a technique to reduce the size of the model. So to give it a perspective, it's like I don't know how many here have background in computer science or computer engineering, but I'm going to share a bit. Data in memory are being stored like into certain can tell them like rules where because when you are dealing with a machine learning model, is mostly numbers. So when you store a number into a memory, it can be allocated a certain space, or like a certain space, and it might vary in size. So I'm not sure if I'm going to be able to make it very simple to understand, but you can have a room, let's say, of 4 bits, 8 bits, 16 bits, 32 bits. Like that's the size of the room where you can store your information. So what they try to do is to reduce the size of the room where that single parameter is being stored. So for instance, if we train the model and we stored the numbers of the parameters into a room or into a space, a memory space, which is having, let's say, 8 bits, we can reduce it and use 4 bits. It's like we are reducing the storage or the amount where we can store a single parameter. And from that perspective, it actually reduces the size of the model, but it has some drawbacks when it comes to performance. Like the performance might go down because I'm going to take that from a very simple concept of decimals. So when you have very large or very large number of decimals, you are granted to have, like, it's more accurate than having very small number of decimals. For instance, when you have 3.2 or 3.2589, when you reduce the number of decimal, you actually reduce the accuracy. So that's one of the drawbacks. So I've talked about a lot of things. Yeah, so I'm going to finalize. So there is another technique, which is retrieve augmented generation. So the session was supposed to be today. You can see it on the agenda, like RAG and the intelligent agents. So unfortunately, it's going to be on the last day. So the speaker won't be available today. The session has been moved to the last day of the conference. So RAG is just a technique. I'm going to highlight it because we're going to have a session on it. So I'm just going to give an overview on what is it. So when we train these large language models, we scrape the internet, for instance. So we take all the internet data and then we train our model. And then after we have trained it, then we have a model here. But then it wasn't possible like that for that model to have recent events or recent information. So for instance, if you remember the cutoff knowledge of ChatGPT 3.5, it was 2021, September 2021, if I remember, September 2021. And then for ChatGPT 4, I don't remember actually. So there was a knowledge cutoff for a certain specific model. Like you can't ask it the very recent information. That's one problem. Like models were not having ability to incorporate the most recent events. That's one. Like the second thing, which you can see as a problem, for instance, I want to use a specific model into my, into solving a certain problem. What I had to do is to take that model and then do transfer learning to my specific problem. Sorry. Yeah, to my specific problem. So this is the speaker. Sorry, I have to instruct you. Let me finalize this and then I'll bring it. So I have to do transfer learning, taking the pre-trained model. As I said, pre-trained model is the model that has been trained on some data, and then I'm taking it, using it into my application. So it was very difficult because you need to have a very powerful computation still to do that. And then, so when you want to do your own AI application using large language model, it wasn't very possible. So as a researcher currently is working for Coheli, I remember his name, actually came with that concept of retrieve augmented generation. So what it does, it just solves the problem that large language model cannot, do not have recent information or do not have my organization information. So for instance, I want to solve a problem that I'm working for a company, and I want to create an AI system that's going to be able to do customer support, but large language model like GPT doesn't know, knows nothing about my organization. Sorry. Hello? Hey, can you hear us?
The voice is very, very low here. We cannot hear you.
Okay, okay. Can you hear me now? Hello?
Yeah, it's okay now, yes.
It's okay, right?
Yes.
Yeah, okay. So I think I have to stand here. So what he was trying to solve is to create a way where AI could be able to, the large language model could be able to incorporate my organization's information into it so that I can use it. For instance, as I was giving an example of I have a company X and I have my own data. I want to create a solution to serve my customers when I'm not there. So I can take that specific large language model and incorporate my data, and it's going to be able to to serve my customers. So what the concept is, you just take a large language model and then take your data. So what it happens, I'm going to talk about it actually in deep
on the session there, exploring large language model, exploring generative AI. So I'm going to talk about a bit. So you take your data, you take large language model, and then when a user asks question, what happens, the large language model goes to my data, trying to search what are the relevant information as per user's question. And then when it gets the relevant information, it goes to the large language model, and it communicates like, hey, from what you asked me, this is what I found like a user information. So the large language model uses those relevant information to generate response to the user. So the response is going to be like something that is actually retrieved from the knowledge base of my company. So you retrieve the knowledge from my data, and then you communicate it to the large language model, and then it's going to compose a response that is actually coming from my data. So that's the concept. Yeah, so I'm going to finalize with one thing, as I was saying. So there is a lot actually for the case of vision now. Back then, for instance, in 2018, you could talk about when you try to talk about breakthroughs in computer vision. Back then, you could talk of ResNet, let's say, the residual networks for image classification and others, but currently you talk about very different things. So you talk about stable diffusion, you talk about the generative adversarial networks, though we are there by that time, but they were not popular. Yeah, so there is a lot of actually also going in terms of vision. We will explore them, I think. So we can take time, and then we have the recent news that happened, because we are talking about the state of AI, and the session is on the state of AI. So this is the state of AI now, as we are finalizing. So the two Nobel Prizes actually this year went to AI people, specifically the Nobel Prize for Physics and Chemistry. So there was a lot of arguments about why the Nobel Prize in physics went to people who actually not doing physics, though John Hopfield is a physicist, but Jeff Hinton is a psychologist and a computer scientist. So I'll just share my views. So this is my views about what happened. The Nobel Prize actually was given because of what John Hopfield did on something called Hopfield neural networks, but also what Jeff Hinton did with actually things like backpropagation, for those who are technically well to know the techniques which are actually being used to train neural networks, including backpropagation. And what is being said is the Hopfield neural networks actually borrowed some ideas from physics, and that's what actually, like, it shows more of physics contributing to artificial intelligence, not as it is being seen as the Nobel Prize in Physics went to an AI person. So it's just like they used more physics concepts to come with. Though in other terms, you can think them of also biological concepts, like when you are trying to mimic a brain, you can think into that perspective too. But also you can think it in terms of mathematics. Like if they were giving, they had that category of Nobel Prize in mathematics, maybe they could offer it for mathematics, but actually there is no category for Nobel Prize in mathematics. And maybe we can explore more. And actually, there is a lot to expect. As you can see, AI researchers are being recognized for what they've done in it's most like 3 decades ago. But also for the case of chemistry, Demis and John Jumper, these are the team from DeepMind. They were working actually on AlphaFold. So AlphaFold is just an AI system that is able to understand the structure of protein and can predict actually maybe different structures which can be formed by protein, either to solve a certain biological case, or if it is either drug discovery, or maybe to combine or to treat a certain disease and other aspects. As we might understand, like protein is a very core component when it comes to how we are formed. So there is a lot actually to talk about, but I'm going to end there and to allow some few questions or additions. Yeah, but there is a lot actually when you say to explore like the whole state of the art currently. There is a lot going on. So let me talk about this challenge. I'm sorry. So I'm glad I found it here. So one of the researchers, he's currently working at Google. The founder, like the creator of Keras, for those who are doing deep learning, you might know that library, Keras. So his name is Francois Corret. So he created a challenge actually to measure how intelligent a system can be to term it as artificial general intelligent system, as I shared previously about artificial general intelligence. So there is this challenge, it's called ARC challenge. So ARC is the short for abstract and reasoning corpus. So it's just the data. So that data is having different patterns. So I think I downloaded it somewhere. Let me try to see where did I put it. I think I had that here. ARC challenge. I don't know if I can see it here. Yeah, let us check it here. Okay, GI. Yeah, so what is happening? Let me share this, I think. Or let me download it here and try to run it so that I can explain it in. Okay. Yeah. So okay. Yeah, so this is happening. Let me reshare the screen. Okay, let me stop sharing. Yeah, so this is the challenge he created to test how intelligent a system might be And in respect that we might refer intelligence as ability to adapt or to navigate through a complex environment, even if they are new to you. So for the current AI systems, which are more likely language-based, in some ways, they're not able to navigate through certain settings which are new to them. So this challenge actually has a lot of patterns where each pattern is new. And what you have to do is to complete pattern based on some of the examples which have been provided. We will try some few examples here. So as you can see here, what is happening? I'm trying to, can you note something from these patterns? From these patterns actually. So there is input and output. If we don't understand this, let me browse another one. I want us to, this is very, let me try something else here. Oh, this is even more complex. Oh, there are easy patterns here. Unfortunately, I can't remember which one is very easy. So this one, I think, yeah, let's explore this. I think we can understand this well. So what can we note from the patterns? I don't know if they are well visible. Let me do this. What can we note? Like this is an input and this is an output. This is an input, this is an output. So what you want to do is to make an AI system very like more adaptive, like because we show it, for instance, we show it this input and we give like this input. So here is the input and here is the output. Then we have this input and we have this output. Then we have this input and then we have this output. So when we give you this input, what is going to be the output? Right? So as you can note here, we have 4 triangles. 2 are having the same color, that is blue, right? And one is cyan, don't know if I remember the color well, and this is red. So when you come here, you can see that the cyan color is on the edges, right? And the blue color is filling the other parties apart from the edges, like apart from the edges. And then the red color is also on the inside edges, like the edge inside the rectangle. So try to explore the second pattern. So what is trying to do, like when you give an AI system this kind of pattern, is it going to be able to generalize on a new pattern like this one? So before we think of a machine or an AI system being able to do that, can we do it? Like, let's explore the second pattern. So the green, also there are 2 similar colors, like which are on this part of the rectangle, and also the green color is on the edges, but you cannot see, like there is a shift of the shape, like the rectangle has moved it to like more like inside, and then the yellow square are on the edges of the on the rectangle, and then we have this one, as you can see here. So how are we going to be able to see, like to tell, given these shapes here, can we predict the output? So there are limited series here, but you can add, like you can choose if you want 9 by 9. It just, so you expand and then, so you can submit and then see if you're right or wrong. Okay, okay, yeah. Okay, let's do this. So this is the kind of challenge he created, and it has been existing since 2019. This the ARC challenge, and the current. Let's see the leaderboard of the performance, and there is a prize actually. So for the model that's going to reach 80% accurate, there is a prize. I think is it 1 million USD. I don't remember. Let's see here. Let's see the leaderboard. So here is the current leaderboard. You can see the grand prize is going to be awarded to the model that's going to reach 85% accuracy, and the current model, which is Minds AI, is having 49% accuracy. But there was also actually some other, they tested some large language models like the GPTs from OpenAI. Actually, they were not. Yeah, here is the performance. So you can see OpenAI preview, like the O1 just scored 21. I think this is the public leaderboard and this is the private leaderboard, if I'm not mistaken. Yeah, so this is the public evaluation, this is the private evaluation. And Crowd 3 Sonnet scored 21%. And O1 Min scored 13% on the public and 9.5 on private scoreboard. And GPT-4o scored only 9%, and on the public leaderboard and 5% on the private leaderboard. And Gemini 1.5, I think this Fresh scored 8% on the public leaderboard and 4.5% on the private leaderboard. So as you can see, this is the AI which we are excited about, the large language models, and this is how they are performing on the challenge like this. So I don't know for a human, and I think they put that 85% is because that's the human performance on this challenge. So by saying those words, I think I'm going to end this session because we have the next speaker here. But because we are here, we're going to be able to continue discussing about that challenge and other recent things. So the session was state of the art, like the current state of AI. And thank you so much. Yep. Sorry, I didn't, I said questions. So if we have questions from online, but also attendees in here, you can ask like only 3 questions to to protect the time of Mr. Alphonse. He's here to tell us about embedded artificial intelligence. So any question? Or we can keep them for further discussions. It's okay. From online, is there any question?
Not for now.
Okay, thank you so much.
Okay, for online people, my name is Alphonse Augustine. As I said, I'm an embedded developer. I have my company called Level Tech. We're still young, it's a startup. And I'm going to talk about embedded AI. Okay, let's define first embedded AI. This just refers to integration of artificial intelligence algorithm data to hardware devices, enabling them to perform intelligence tasks without relying on cloud computing or extensive processing, external processing. As you can see here, it's a sample of an IoT architecture. As I told you that we are going to talk on electronics. Let's take an example that here we have a farm, maybe, and from our farm there, we usually have these devices that interact with the physical world. Maybe sensors, maybe if it's a farm, we can have maybe sensors that may measure humidity, may measure water level, and whichever around that we need to measure, maybe temperature, didn't it? So in most cases, we usually connect them with in a network, whereby in a network, we usually have a gateway. In the gateway, we usually have a server or the cloud. And that's what I've shown here. These are just simple. And these, since are on the networks, they are also called edge devices. We use them to call edge devices. That means that there are points on our network, on our IoT networks. There are usually many. And sometimes we can meet the word that come across with the word maybe edge AI. So edge AI, what it means is doing AI on this device, small device, that device which interacts with the physical world. Let me take you to my sample projects here and you understand what I meant. Here are my two projects. The first is Game Reserve Spy Camera. I'll tell you also why did I name it Game Reserve Spy Camera. The problem was that we had a lot of challenges while the problem was that people living near national parks, game reserves, had been disturbed with these elephant attacks and other dangerous animals living in those national areas, national parks and game reserves. So they needed to make sure that those animals to have a system that will not allow them to leave their places to the habitat where people live. So we had to make a camera to detect. I don't know if here it will play, but let me try to show you. It's just a demo project which I did. Okay. There's no voice, but I meant YouTube. Auto share. This is a part of my project. This is a control room, but also that's what I've mistaken. Sorry. Okay, but the project, what I meant to do is to, this is just my control room for my project, but the project ambao nilitendi kufanya ilikuwa ni kwamba nazuia tembo kuvamia maeneo ya watu. Tembo na wanyama wakali kwa detect kwa kutumia AI. Kwa hiyo niweza kutengeneza kamera ambayo ilikuwa inaweza kuwa detect, alafu ikatoa alarm control room na kutoa location za just simple words. Ndio ilikuwa hivyo. Sasa hii inaweza nikaiongea hivi mtu akaona kama ni kawaida. But when you come to an embedded AI, kuna vitu lazima uviconsider. Kwa mfano, kumbuka tumeenda kufunga hii project, let's say Serengeti National Park. There are thousands of kilometers there. Ukisema kwamba uzunguke ile eneo ufunge cameras, there are thousands of kilometers. Sawa? Na kama nilivyokuwa nimeonyesha hapa mchoro wa IoT, let's say kwamba hizi ndio camera, these are my cameras. Nimezifunga across the boundaries, zinawasiliana through the gateway and to the cloud. Sawa? Kwa ajili ya server room au nanili pale control room. Changamoto inayokuja ni kwamba when we have maybe 100 cameras, both of them streaming high quality videos to their servers for processing, hii server itakuwa na load kubwa. Sawa? Fikiria kama ni video 100 zinakuwa uploaded zote, zina stream, alafu kwenye server ndo unafanya hiyo AI. Kwa sababu una large power. As the project grows, tegemea kwamba hii server inaweza kazidiwa au processing power ikawa ndogo. Kwa hiyo unaongeza na in this world now we are in the world of edge devices or IoT also inakuja hapo. Kwa hiyo nilichokifanya nikafanya kitu kinaitwa edge computing. Edge computing ni pale ambapo unaamua AI ifanyike hapa. Kwamba kwa kutumia kamera, just on the camera, AI also is performed. Kwamba hapa kupitia kwenye kamera hii AI inafanyika, nyama anapopita inatambua kwamba huyu ni tembo, kwa hiyo inatoa taarifa, inatuma tu taarifa. Kwa kinachotumwa badala ya video inatumwa tu taarifa. Just bytes, small bytes, kwamba kuna tembo ametokea sehemu fulani na location ndio kinatumwa kwa sababu imefanyika hapa. Sawa? Faida ya hii inasaidia nini? Kwanza nimepunguza kuifanya network kuwa busy. Sawa? Kustream a lot of videos kila muda inafanya network kuwa busy throughout. Na sometimes tunasema kwamba tunasema isende kwenye nanili, tunasema kwamba network inakuwa so busy na vitu kama hivyo. Lakini mbali na hapo, unapotuma just information ambazo zinahitajika kwenye server, unafanya network yako kuwa more efficient na performance inaongezeka pia. Sawa? Hiyo ni one of my projects that I've done. Another project was illegal deforestation detection using machine learning. This project was detecting illegal deforestation activities katika maeneo ambayo imezuiwa kukata miti. Basi na kutengeneza mashini ndogo ambayo you put it there and kama mtu akija kukata mti bila idhini yako utapata notification kwenye simu. Hii pia inatumia machine learning. Hii pia ni faida ya embedded AI. Na iongee kwa sababu ni faida ya embedded AI because it was one of the projects that kwamba we needed also to stream audio. The way nilivyoifanya hii ni tumia audio. Sawa? Kwa maana yake ni niweza kucapture those audios tukazifanyia processing, nikatengeneza model kwa kutumia Librosa. Kuna library inaitwa Librosa when you are talking about AI on sound, will come across Librosa and we created a model that we made it to learn on a small device. Ambayo small device unaifunga katika msitu wako au katika shamba lako la miti, ambao kwamba mtu akija kukata mti direct wewe unaweza kumaccess kwamba okay, kwa mtu anakata mti sehemu fulani, unaweza ukaenda na ukamkamata. Ilikuwa ni ngumu sana kwenye mashamba maelfu, kwa mfano ukapa Tanzania, tuseme labda tuenda misitu fulani, tuenda kufunga hizi devices kudetect illegal deforestation, alafu at the same time utegemea kwamba server tu ndo, yani kwamba uende kwenye server, hii server hapa juu au cloud yako ndo itegemea kwamba uipe mzigo wote. Kumbuka tunapoongelea edge devices ni devices nyingi, zinaweza hata milioni 5. Sasa think about 500 devices streaming audio ili uweze kufanya AI katika server zako, inakuwa ni uongo. Sawa? Kwa hiyo kitu ambacho kinakuja kutokea ni kwamba you have to do it on the edge. Unaweza kaifanya direct hapa au pengine ukawa na just capturing device afu unyoka kaifanya hapa. Kuna levels unaweza kaipanga. Unaweza kaifanya direct hapa au kaipanga kidogo kwamba devices 3 zinakutana, labda let's say kwa mfano katika budget nachukua camera, maybe have 5 camera or 6 camera. They can stream either their video or audio to a single Raspberry Pi moja. Kwa kila Raspberry Pi moja ambayo labda ina cost $500 ambayo ni gharama kubwa, nina connect na kamera labda 4 au 5 kwa ajili ya kwamba zile devices ndio zina stream hapa, inakuwa sio audio lakini na stream hapa ndio inafanyika afu inasema. Lakini tunafanya kwa ajili ya vitu kama hivyo nilivyosema. Na sorry. Okay. What are the challenges? Sasa, what are the main challenges in embedded AI is that these devices which we are using in IoT are very small devices. I haven't come into the sample today, but we can think of an Arduino. So for those who have met an Arduino, an ESP32 microcontroller, we have the Raspberry Pi, we have the BeagleBone, and so many more. There are small devices that they are very resource constrained devices. Take an example that an Arduino, maybe this what ESP32 have only 32 MB in memory. Then how do you do machine learning on that device? How can a model learn on that device? That's a first challenge. Another challenge is that, so there are some devices, even in IoTs, that we cannot embed AI still, but most of them until now they do support. But also another challenge was algorithm complexity. As we know, this machine learning are very complex models, so we need to have a device that are capable of learning these complex algorithms. But also security. I won't talk about the benefits now. I think we are going to pass through those challenges. But what I need to say on challenges, for a person, I'm here to inspire on the embedded devices, on embedded AI. I've put these challenges to let you know that nowadays we have this called edge computing, edge impulse. I haven't written it here, but you can just search it. It is called edge impulse. Edge impulse is a platform where we, embedded developers, we can build our models that are going to specifically learn on these devices. Na uzuri wa edge impulse wanakupa mpaka zile code, sample codes ambazo zitakusaidia wewe kuanza unapoenda ku-deploy hiyo model yako. Kwa hiyo what you have to do is to just choose the right microcontroller that you're going to use. If it's Arduino Uno, or maybe Berlisen 33 or whichever, una choose. Kwa hiyo inakusaidia kwamba usikutane na a lot of code, kwa sababu hizi devices they are only 8-bit microcontrollers or 16-bit microcontrollers. Ni chache sana zinaenda 32-bit microcontroller and 64. Or you can see that they are very small devices. Kwa hiyo hizi challenges zinakuwa solved unapojiunga katika embedded na ukakutana na watu kama Impulse wa kukusaidia wewe kufanya hizo model zako kiurahisi. Sawa? Kwa sababu nikasema kwamba it's a lot of coding. Kwa hiyo benefits I think nimeziongelea nyingi. The first one is reduce redundancy. That means that we are going to have this fast response, and also the network won't be busy, and we have lower bandwidth usage. I think it's in some case on what? On the network, and we have energy efficiency. Energy efficiency naomba hii pia niangalie vizuri zaidi. Sawa? Katika IoT, energy efficiency ya devices zako ina matter na environment ambayo unaenda kuifunga. Kwa mfano, mimi nimefunga hapo kamera. Sawa? Nataka hiyo kamera itumie battery. Sababu kila sehemu ina umeme. Fikiria an example kwamba nimeenda kufunga in national reserves. Sawa? Pale we don't have electricity. Even though we can say that we can have a solar panel, I mean small panel, but a solar panel ya kuweza kuipower kamera kustream au kufanya AI katika hiyo mazingira labda hiyo kubwa sana. Sasa ikiwa kubwa sana unaenda katika high cost tena. Kwa kinachotokea ni kwamba pale unaweza ukawa na vitu, kuna kitu tunaita technique za kubalance your battery. Kwa sababu unavyotengeneza small devices, unapofika katika hizo small devices na ukaambiwa kwamba sasa tunataka solution, ni lazima useme kwamba hii device naifunga hapo mlangoni. Fikiria labda mlango ule, this smart door locks, ndio? Smart door locks unaweza kaifunga hapo mlangoni ikakaa miaka 5 bila kuicharge bila nini. Inabidi iwe hivyo. Kwa nini? Kwa sababu pale anaweka technique nyingi. Technique ya kwanza ni sleep. Yaani kama mtu atumie mlango ita sleep automatic. Sawa? Kwa hiyo unapofika ukibonyeza ndio unaiwasha. Ukiwasha utatumia baada ya zima. What about on the camera? On the camera tunakuwa na devices kwa mfano motion sensor. Nimefunga kamera pale. I have my motion sensor over there also. When a person is passing, motion ikiwa sensitive, ndio kamera itawaka. Ikiwaka itafanya hizo AI ambayo unataka ifanye. Sawa? Kwa maana yake kinachokuja kusaidia ni kwamba inasaidia battery pia kuwa na uwezo wa kukaa muda mrefu. Kwa sababu ukisema kila muda ulani AI throughout on the video, hata kama umeweka solar panel ndogo, unaweza kushangaa hiyo model yako isifanye, yani sio applicable. Sawa? Kwa kuna hizo technique ambazo tunazitumia. Sawa? Otherwise, I think my session ni ndefu sana, and that's my end. Labda tu nahitaji to discuss kidogo kama kwa mtu atakuwa na maswali, or anyone who let me use English, sorry. If there's anyone who has some questions or an idea needs to share on how to use this AI on the embedded systems, nakaribisha jamani sana. And you are welcome. Anyone who has a question, please. Katika kufanya AI katika small devices. Anyone who has a question?
We actually have one here from Mr. Madam. Yes.
Ask it.
Yes. Hello, hi, am I audible?
Hello?
Am I audible? Can you get my voice?
Yeah, okay.
Okay, I have 4 questions.
Okay.
But then first, thank you for the presentation. Though at the beginning of the presentation, your audio was a bit low, so maybe I could not get most of the answers from there. So that's why I have a few questions for you. Number one is I was interested in understanding how you're utilizing edge impulse in connecting machine learning and embedded systems. You just spoke about it, but I don't see how it's linked. Because you just said that when you're going to edge impulse, you just need to identify the specific microcontroller that you're using. But I don't see how you link to the microcontroller and the edge impulse and why I should know the specific microcontroller that I'm using. Number two, still on the edge impulse, I don't know, is it a cloud platform, a cloud storage platform? And if it's a cloud storage platform, does it mean that that's where you deploy your model, or you deploy the model within the microcontroller? It's a question because if you're deploying the model within the cloud, there's that distance, there's that delay from the microcontroller to the cloud. Do you factor that as one of the disadvantages, or it's one of the areas that needs further research? The other question is, what is the current trend within the embedded field in terms of machine learning? We have microcontrollers where you can deploy the model within the microcontroller instead of deploying in the cloud and then connecting the microcontroller in the cloud. And then the last part, just 1 minute. Yeah, I think we can handle those ones first. I think they are a bit clear.
Okay. Okay, starting with the first question, why should we use these cloud platforms such as Edge Impulse? I think Edge Impulse is just a platform to support you as an embedded developer, that to not have lots of code. Maybe I think it's a lot, because in most cases we usually use C. In embedded devices, in most cases, when we need the high performance, we usually use C. And we know C++ is hard, C is also hard. And doing machine learning using C sometimes might be very challenging. So in most people, especially we embedded developers, we usually have an option. For those starters, it's advised to use Edge Impulse. It's advised to use Edge Impulse to train your models over there, and they have this what we call that their sample codes. In fact, in really that Edge Impulse, it only helps you to build your first model, first 2 or 3 models, to know how these models can be trained on the small devices, and how their sample codes on deploying them on small controllers might look like in C++. How to embed those libraries, how to create the libraries, your own libraries. But after there, for example, me here, from my 2 projects, none of them have done with Edge Impulse, because that was just my starting to know that how should I use my controller on deploying such model. In explaining further, let me explain more there. You know, on embedded devices, it takes example, it's a camera. When we have a camera, we expect that maybe it's a Raspberry Pi with a camera. We expect it to have in most cases two processes running at the same time. First is the camera recording, and the second is an algorithm that runs that machine learning model, deep learning model, to detect the presence maybe of those elephants. So in most cases, for we embedded developers, we need to separate which processor should work with the camera and which processor should work with the model. We usually call these real-time operating systems. So sometimes it's very hard for a beginner to train his own model and also deploy it on the small devices. And that's why we usually use Edge Impulse to help us to know a little bit code. So, and we don't deploy them on Edge Impulse. Edge Impulse is just for training purposes and deploying them. You have also asked about the trend of of embedded AI currently. Currently in IoT, the whole world, we are looking for a device or an IoT system, an end device, an edge device that will going to run forever, maybe not using battery. In Swahili I can say that tunahitaji kutengeneza vifaa ambavyo au sensa ambazo tukizifunga sehemu zitalani maisha yote bila kuhitaji battery au kuhitaji umeme wa aina yoyote. So with that case, and that's why I've been explaining here that sometimes we have to look on the battery, we need to look on the in more things like that how do this system, kwa sababu kwa mfano mimi nimeenda nimefunga Serengeti kamera yangu, nikiwaambia kila baada ya wiki waenda kabadilisha battery hawatanielewa. Sawa? Kwa maana yake inabidi nikifunga leo niwaambie baada ya miaka 10 ndio mnaenda kubadilisha hizo battery au lifetime. Kwa maana yake hiyo ndo trend ambayo ipo kwamba tunachokiangalia in embedded devices also kwamba we are looking kwamba when we are learning these models on these edge devices, they should learn at least for 5 years and more without charging them. But also another trend is that we are looking also to have this other trend is this enabling them to learn models such as unsupervised learning, that to let the machine learn on its own environment. Yeah, those are the two trends which I can say that we have in embedded systems. Kama kutengeneza mashine ambazo zitaleni kutokana na eneo na zitasaidia watu kutokana na mazingira. Pengine kuleni hata lugha mpya na vitu kama hivyo. Take an example kwamba sasa hivi tunahitaji, I'm talking maybe in Swahili, and since I'm using the microphone, take an example that you can switch to Spanish or whichever language you need. That's automatic translation, and that can be done through embedded devices. So, our brother alikuwa anaongea kuhusu large language models, and one of the days I posted that I need a challenge to only large language models to be used on embedded devices, and one of them is that we need to translate data translation of the microphone, person speaking to the one using earphones to listen in or her own language. So you can think about it also. Hizo ndo trend ambazo tunaenda na they are very sophisticated na tunaweki nazo mpaka sasa hivi, and that's my projects that I'm now doing. Any question maybe if I have answered? Did I answer all your questions?
To an extent you answered, but then I think let me leave it at that point. I might do some further research on the same questions, but thank you for your response.
Oh, thank you. Okay, this Emai is asking, how did you deploy a model in the resource constrained device in your 2 projects? Which of the devices did you use exactly? Did you use any of the model running or compression techniques? If yes, how did you use performance measured? Okay. Here, Emai can answer you that. How did I learn these models? My first assistant was Edge Impulse, because it's where I knew that when should do this processor do what. It's hard to explain now here that how real-time operating system is working on embedded devices, but you are the one who you are going to program that controller, that which processor should use. I think you should read more on real-time operating systems. Real-time operating system on embedded devices, because when you are learning machine learning models, sometimes we don't like, always haraka naweza kusema kwamba uwezi ukarekodi video sasa hivi afu baadaye tena uende kwenye picha afu video umestop. Kwa sometimes inabidi vilani simultaneous. Na ndio kusema kwamba unatumia pale real time operating systems, inabidi usome uelewe. Sawa? Na hivyo ndio nilivyofanya. Kwa hiyo ndio maana kasema assistance kubwa ambayo ndio kaanza nayo ni aging pass, wanakupatia sample codes ambazo zitakusaidia wewe in your next model. Sawa? I think ndio hivyo nilivyofanya pia, ila nitumia model zangu alafu nikaziconvert. Kuna kuconvert model from Python to C. Kushaka kwenye C then ndo unaideploy vizuri kwenye model yako, kwa sababu ukatumia Python katika edge devices. Ipo MicroPython but inahitaji uwe pia na microcontroller kubwa ambao pia itakula spaces. Sawa? Yeah. Mwingine mwenye swali hapa katika chat room online au hapa? Karibu.
Yeah. Thanks for the very good presentation. Sorry. Thanks for the very good presentation. I wanted to learn from you, what is the market like when you deploy with ML on the edge? I understand you also have a startup. What is the market like for solutions developed on the edge devices?
The market, to be honest, is still hard to me, and that's why I joined also. I joined the FANEA, because I was doing these models and my only market was the government. As you know that these projects also, they cannot be, it's very difficult to sell it to individuals. So my market was the government, and now until now from these projects too, one of them, it's doing good now. Nasubia kuitwa. Sasa I cannot say about much about it, but ndo hivyo. So it's very hard in these countries. I've answered the dilemma. Maybe if there's another. Can send a question, yeah. But to add on the market, now we are doing also, we are still also exploring on how we can use AI on agriculture using a embedded device. And we have a project that is going to help us produce more au kupunguza gharama za uzalishaji katika mazao ambayo tunasema hii nini, aeroponic farming. Who knows aeroponic farming? Yeah. So we have a project. Aeroponic farming. Maybe you might explain also.
So hydroponic farming is it's a modern type of intensive farming where you don't necessarily need to use soil. You can use some nutrient solution, and then most of the time they do vertical farming, so that in Kenya land is becoming ridiculously expensive. I don't know about here. So if you have like a room like this, you can put rows of let's say like you can even use PVC pipes, and then you connect systems, and it uses also water very efficiently. Like you can use 10% of the water you'd use in a normal farm, and the yields are faster. The nutrient solution makes, and then you control the environment, so you can have LED lights, you have temperature sensors, and you can grow food 365 days a year, and you can feed your whole village with just this room of maybe you're planting vegetables. So it's a very new and brilliant way of farming.
That's a brave explanation. I didn't say that, but also to add on it, our project is going just to base on on reducing the electricity cost. We need to rotate water through these aeroponics farms throughout, isn't it? So we are now dealing on how one can use, one can generate electricity automatic and also, yani kwamba asitumie umeme kabisa, either TANESCO or whichever, ili aweze kupata products. Umeme upo juu sana kwa nchi zetu, sawa? Kwa sasa sisi tunahangaika kutengeneza namna ya kwamba umeme, yani maji yakianza kuzunguka yazunguke throughout. Sababu katika aeroponics farming tunachokihangaika ni kuzungusha maji. Sawa? Lakini pia kwenda mbele zaidi kuangalia nutrients gani zitahitajika muda fulani. Sawa? That is hiyo itakuja baadaye. Sisi tunaanza na maji kuzungusha ili uweze kuproduce, ili mtu aweze kulima kwa umeme, yani tunasema ni kama kilimo cha umeme. Sasa na sisi hapo kwenye umeme na sisi ndo tunaingilia kwamba tutoe zile cost za kutegemea either TANESCO kama umeme utakata au kutumia solar ambapo wengine hawataweza, au pengine wewe unataka kulima ndani kama ulivyosema brother. Sawa? Umeelewana? Kwa hiyo hapo sisi ndo tuna apply. Hii ni kama pia sister hapa alivyouliza kwamba about the market. Kuna sisi katika market tumeona kwamba tukifanya katika level ya agriculture ni watu wengi tutawaface na sio kutegemea tu aidha serikali au watu fulani. Sawa? Yeah. Any question maybe? Basi tuende. My name is Alphonse Augustine and thank you. And thank you also my brother Zephania here. And welcome to Embedded Systems and AI.
Thank you so much. Thank you so much, Augustine. We really appreciate your time. I know alikuwa kazini, kwa hiyo imebidi aje atupitishe kidogo kwenye embedded system. Yeah, thank you so much. Yeah. Yeah, so I'll share also a bit of my experience with embedded system. So last year we worked on a challenge. It was a challenge from ITU. It was, what was it? I don't know if I remember. Let me check here. The essence of the challenge was to detect animals. Let me find it here. I think it is one. Yeah, so you have to forgive my internet.
Hello, everyone. Good morning, good afternoon, and good evening.
I think I cannot get it. I think I can get it. So let me share it. Yeah, so it was a TeamML challenge so there are different categories, but the category which we worked on was on detecting wildlife. Like it was wildlife monitoring. So where we had to train a model on different kind of animals, such as elephant, zebra. Like it was around 10 categories, and actually we won. The yeah. So we won, like we were the first press winners of this challenge. Me and my team actually we worked on it under the AI for D Lab. So I'm just going to tell a bit about the process, what we did to the deployment part. So I did the training actually of the model. So because I did it, I used the first I used TensorFlow. I mean I used the PyTorch because that's my favorite library for doing deep learning. But then it was a bit complicated, like to change a model from PTH, like the serialization format for PyTorch, to a model that can be deployed on microcontrollers. So I had to shift and use Keras and TensorFlow. And then at the end, so we had a model saved into TF-Lite, I think. So like it's a very suitable format for deploying models into microcontrollers. So there was a process actually, I remember I tried to convert from PyTorch to TensorFlow Lite. So you have to change from PyTorch to the model. I think the format's called Onyx, if I remember well. So from PyTorch to Onyx, and then Onyx to TensorFlow Lite. So TensorFlow Lite has been renamed. I don't remember the new name, but it has been rebranded to new name. And it was a good experience, though I didn't go to the hardware part, like the deployment part. So after converting the model to TensorFlow Lite, that was my, like I ended there, and then other team members worked on deploying it into a microcontroller. So, but at the end, we won the challenge, and it was a good experience actually. Yeah, so I wanted just to share that. So if you want to work on embedded AI, you can follow specifically TNML, Edge Impulse, as Augustine said, and the other platforms that can help in building embedded AI. So that was to conclude. So we are taking a break like of 10 minutes, and then we are going to be here for the next session on exploring generative artificial intelligence. So yeah, for the people online, we will be back after 10 minutes. Thank you. Yeah, so sorry, we were having an activity here, so it wasn't that necessary for you to hear, but we were playing a game. Yeah, so we are back, and the next session is on like we need to explore different aspects of generative AI, and we actually we were supposed to have Brian Koyundi presenting. He got an emergency, but he will join us. He will join us tomorrow. So he will join us tomorrow. But for now, let's explore some of the key concepts of generative AI, as today is more of an introductory day. So yeah, if you have any question, you can just drop it on the chat box, and then we're going to respond to the questions. Okay. Okay, I haven't shared this. Yeah, so as you can see, there are 3 terms there, LLM, generative AI, and retrieval augmented generation. We are going to have a session. Tomorrow, specific on large language models, open source large language models. But I'm going to highlight some of the key concepts. But also, we're going to have a session on RAG and intelligent agents tomorrow. So expect that to happen. But this session is actually going to highlight, but it's going to be more of a discussion about these issues. So if you have any question or you have anything to share, to add, to comment, you are warmly welcome. So here are some of the common use cases of large language models, and why we talk about large language models, because these are it's like the engine of the current state of generative AI. Specifically, there are different techniques which can be used for generative models. So we have adversarial network, as I shared, generative adversarial neural networks. We have diffusion models. We have energy-based models, but also we have these autoregressive language models. So, but for this case, you are going to be talking more of autoregressive language models, because that's what is driving the innovation now. So if you want to explore more about diffusion models, because actually we don't have any session for this conference covering diffusion models or energy-based models, but we're going to talk about autoregressive language models tomorrow. And here are some of the use cases, like the common use cases of large language models. So the first one is summarization, and most of these, I hope online people can hear me well. So we have summarization, we have translation, we have chatbots, we have information retrieval, code generation, and questions answering. So these are the common use cases currently. And I want to put into perspective the concept of large language model. Like we have understanding of what we really mean when we refer them as large language models. So the first, it's not the first, but the most popular back then, around 2018 to 2020, this model built is bidirectional encoder representation transformer. I think if I remember, it's the wrong form. So it was having 110 million parameters. So I shared earlier, like in most times we quantize the size of large language models based on the number of parameters they have. And to put it into context, as you can see there, that's the Bloom, like that was another large language model, which was released there, if I'm not mistaken, it was around 2022. Yeah, earlier 2022, I think. So it was having 176 B parameters. So it's like, if I'm not mistaken, 10 times the Barrett model. So that's how large that was. But what actually mean to refer them as large language models? So we talk on the pre-training stage. The pre-training stage is where we collect data, specifically maybe we scrape the internet, or we collect different we collect data from different sources, if it's books, anything that exists, and we face important to use it. And then we put in place the computations, and then we put in place the people, the talent to work on that, or to engineer the process of training the model. And then we have a pre-trained model. But these are the things I was saying to put in place. And then you come to think of what is the challenge. Specifically, it is being seen as a challenge, specifically into our context, because we face it, but we might be having a lot of challenges apart from computation challenge, which we always talk about. So, but I'm going to highlight in the big picture of what, when we say we have computation challenge, what it might look like. So to store one parameter, as I shared earlier, you need 4 bytes. And you're going to use like 32 bits. Like that's to store a single parameter. That means when you want to store 1 billion parameters, you need a memory of 4 GB to store 1 billion parameters. And this is just for only model parameters. So when I say model parameters, for those who are not experienced or don't have that background in machine learning, I can put it into perspective this way. So my example, I think is going to be relevant to everyone, because at one point we all did basic mathematics in Form 1. So that's my first assumption. Yeah, we all remember the equation of a straight line, right? The equation of a straight line. Do you remember it? Y is equal to mx plus c. Tunaikumbuka? Y is equal to mx plus c, right? So to think about it, it's like ili upate y inabidi uwe na nini na nini. Inabidi hizi variables zingine huku zote zilizokuwa mentioned ziwepo, si ndio? Like the coefficient m, si ndio? Na ile y intercept ambayo nini? Ni c, si ndio? And in most cases tulikuwa tunaambiwa kutafuta m na nini? Unaweza ukaambiwa kutafuta m like the slope, si ndio? Au kutafuta c like the y intercept, si ndio? Lakini kwenye hizo kesi zote unakuta umepewa x. Sawa? So consider x as an input, si ndio? Consider x kama input, halafu y kama output, halafu m na c ni namba ambazo unatakiwa uwe nazo ili zikusaidia kupata nini? Kupata y. Ndio. Sasa when you are training a machine learning model, just in a very simple overview, kazi yako ni kutafuta m na c ambazo ni best kukupatia correct y. Sawa? Si kama nimeiweka into perspective kwa simple terms. Sijui kama jaribu kuwa as simple as I can. Sasa tunakuja kwenye concept ya parameter. Sasa ile M na C we can consider them as parameters. Umeona kwamba tukiwa na zile M na C, tukileta X yoyote tuna uhakika wa kupata Y, kwa sababu Y ndio output. Kwa hiyo tukiwa na M na C, anytime tukileta X we can get Y. So kwenye large language models hiyo M na C ndo unakuta ziko ngapi? Ziko billions. Sawa? Kwa hiyo you have billions of M and C zinakusaidia kupata nini? Kupata Y. And you have to store them somewhere. Si ndio? Kwa hiyo kustore hizo M na C or the parameters bilioni moja unahitaji memory ya 4 GB, si ndio? And to store them 175B unahitaji memory ya kiasi gani? 14,000 GB, si ndio? Swali, kompyuta yako ina memory kiasi gani, like the RAM? Maana yake nilitolea mfano wa hii belt ilikuwa na 110 million and then Broom ilikuwa na 176B ambao ndo close to this one, mfano hapo 175B. So you need to have 14,000 GB RAM, si ndio? And then for instance my computer iko na 16 GB RAM, si ndio? Sasa 16 GB zinaingia ngapi hapo? Sawa. Sasa maana yake ni nini? Fikiria sasa hiyo ni 16 GB alafu possibly nimenunua kwa gharama fulani, si ndio? Sasa and which is might be very costly for instance. Sasa imagine you want to reach 4,000 RAM. Kwa mfano kwa kompyuta yangu hii unatakiwa uwe nazo ngapi alafu ni za shilingi ngapi? Si ndio? I'm trying to put into perspective like how the computation challenge ambavyo iko specifically katika context yetu na approach gani ambazo tunazitumia kufanyaje ku address hiyo challenge, si ndio? So hapo nilikuwa naongelea hizo ni zile parameters au knowledge stores za model, lakini kuna parameters zingine ambazo zinakuwepo wakati wa kutrain. Tuna memory stores ambazo zinakuwa zinatunza gradients kwa wale ambao wako kesho tutakuwa na session on classical machine learning, kwa unaweza kupata the concept of training ML algorithms. You need to store the gradients, you need to deal with optimizer ambayo inakuwa na states zake, lakini you need to have also a tempo memory. So that's all the storage you need. So to add something on that, ukinunua Nvidia, like Nvidia A100 moja ina GB 80. So can someone help me to Google like the cost of 100 GPU ni shingapi? The cost of 100. How much? Yes. In USD, in TZ shares, for instance, let's say in TZ shares, 41 million. So to get a one Nvidia A100 GPU of 80 GB, remember it's 80 GB storage, you need 41 million, right? And to store a model which is having 175 billion parameter, you need 14,000 GB. And to buy this one of 800 GB, then you can think of how many 800 GPU you need to be able to deal with this model. So we can do mathematics there and see the total cost. 200 GPUs. Yeah, 200 GPU, then multiply by the cost of single GPU. $954 million. It's billion, right? Billions of money, right? So when you think of it as an individual, it's very hard to have that capabilities. Like I can't even think of it, right? And it's not only here in Tanzania, but even the West, you can see the companies which are doing that work are the bigger companies. You are talking of Google, Meta, OpenAI, of course, and other companies. So how do we solve this challenge as Tanzanians who are building or who are aiming to build solutions to solve our local problems using AI? What ways should we use to do this? So this one was for a model that is having 175 parameters, B parameters. So I'm adding another context. GPT-4 is estimated to have 1.76 trillion parameters. So you can think of how much computation you need to deal with it, right? So how do we solve the challenges? An idea? I think online you can hear me, right? Anyone can confirm that? Hello? Okay, yeah. Thank you so much. Good. Yeah, so I was trying to put it into perspective of how much it costs to deal with large language models, specifically in our context. So what is the solution? I want to hear from you. Welcome. Let me bring your mic.
Okay, I think to build on top of existing pre-trained model.
So one of the solutions is to build on the existing models or infrastructures. So that is one. Thank you so much, Henry. Any other thought? Yeah, Brother Karen, first, thank you for coming. I didn't expect you here, but you made it. Thank you so much.
So, yeah, I was in Nairobi Innovation Week and we were speaking of the same thing, like, okay, this is a fair ground to compete. And there's one guy who said, if you don't have billions, don't innovate around building foundation models, because there's so much which can be done as on top of that, right? So that was like another the suggestion. So if you can at least took already like Llama, it's already trained with massive data, million have been invested on that thing. You take that model and now just twist your data, maybe I don't know, fine tune it, yeah. But I think for what I want to say that I think LLMs are like foundation technology, and there's so much can be done on top of that. So yeah, I think that's what we focus to here. That's my
yeah. So Caleb also tells us like we should focus on building on top of the existing foundation models, because so much has been invested there. We can leverage that investment actually that has been done. So thank you so much for sharing. So my thought too. Yeah, so, and I think that's what we are currently doing. So we are currently doing that. We are currently leveraging the existing models, specifically the open source infrastructures that has been built. And to be specific, as Karib mentioned, Llama foundational models are there. And at some point, of course, it's not a fair ground to compete, but it's very difficult to convince. I don't know, Madam Dina, you can tell us also from your experience what you can do, because at some point maybe we need to either to have something of our own. Is that is that possible? Can we think of can we think in that terms? Like we can have something of our own. For instance, I think India, they've built something. I don't know, it's called what? I don't remember the name. There's this foundation model has been built by Indians. I don't remember the name. So I would appreciate to hear thoughts from Madam Dina, because she has been in the industry for a long time, and maybe we can have some.
I actually echo what Caleb said. Investing on the foundational model is very expensive. So really, we should focus on solutions on top of the foundational models, and those solutions are context-wise. So we really, they reflect. And also like investing on developing data sets, which are in our context, say Swahili data sets in different contexts, that will definitely put ownership and have them on top of this. Foundational model makes more sense in terms of investment currently.
Thank you so much. So I got something actually new from Madam Dr. Dina about investing on data set. I think that's very important. So because we have the infrastructure already, so what are we going to be working on? Possibly, I think the concept of investing on data is very, very important. So we have some of the, as we heard from Dr. Dina and Caleb and Henry, on leveraging the existing ecosystem or the existing infrastructure. So I have highlighted some of the strategies actually to leverage the existing infrastructure, specifically the open source infrastructure. So the first approach is quantization. Quantization, as I'll talk about it, but we also have multi-GPU computing strategy, which is actually also needs some number of GPUs, but it might not be very costly compared to building from scratch or like doing pre-training. But another approach is LLM fine-tuning, but also we're going to explore another approach which I didn't highlight here, and that is retrieval augmented generation. So when we like, let me start with so I want actually, I will be focusing on fine tuning. So that's why it's bolded there. So I have already talked about the quantization process. The multi-GPU strategy is just like doing parallel programming on multiple GPUs, if I'm not mistaken. But let's talk now about LLM fine-tuning. So fine-tuning, I shared a bit about it, but actually I didn't say if that is fine-tuning when I was talking about the transfer learning. So you have a model that has been trained somewhere else, and you take that model and you have your own data, then you train the model or you fine-tune the model on that specific case you want to solve. So for instance, here we have the pre-trained model there, and then we take the data, and for this case, because we want it to solve a certain specific case, so we have like a small, for large language models, more of prompt compression pair data. So if it is question, let's say it's a question and response. And on this process, actually, I have someone there who worked on something similar, like something like this, which I'm talking about. So I think Onani, you will share on what you did actually to create a data set. So you have prompt completion pair, and then you fine tune the large language model, the pre-trained large language model, and then you get the fine-tuned large language model. So I know someone has this experience. They were working on a certain case. Onani, can you share a bit about how you generated your data? So, and what you are trying to solve, actually the problem you are trying to solve, so that we can be referring to what people are building straight. Yeah. But you can explain the problem first.
Okay, I can explain the problem first. The problem we are working is about the law. Our society in Tanzania, most of youth are facing the problem they do not know the laws of their country. So we are working on the project known as Law Guard. Hiyo project imedili kuelimisha vijana kuhusu sheria za nchi na watajilindaje pale watakapopatwa na majanga. Mfano, umepatwa na kesi, unatakiwa ufanye nini ili uwe safe, kulingana na sheria gani zinakulinda wewe hata polisi watakapokuja kukukamata. Kwa hiyo changamoto moja hapo tulokutana ni kwenye process ya kufanya data preparations. Tumesearch sana, ila watu wengi wanaonesha jinsi ya ku fine tune model, ila kwenye kipengele cha kuandaa data inakuwa ni ngumu kuonesha. Tulitumia pre-trained model ya alama 3 8B parameters. Kwa hiyo inahitaji maswali kama 1000 kutoka kwenye document yako. Je, utawezaje kutengeneza hayo maswali 1000? Kwa hiyo walitumia JSON files. Hayo maswali yanatakiwa kwenye format ya JSON. Kwa hiyo kwenye format ya JSON wanatumia format tofauti tofauti. Kuna wanaotumia prompt, kwamba anaingiza prompt, kuna kipengele cha prompt ambayo inakuwa ni user swali, mfano wa swali atakaloliuliza user, afu kunakuwa na, naweza nikaonesha so tukiendelea kwenye kipengele cha kuprepare data. Kwa hiyo kuna format tofauti tofauti kulingana na model utakayotumia, kulingana na jinsi walivyoandaa zile data zao. Walama 3.18 billions walikuwa JSON files zinakuwa na data zile unavyoanza kutengeneza maswali yanakuwa kwenye yana format 3. Kwa hiyo utakuwa na prompt ambayo itakuwa ni swali user atakaloliingiza, afu utakuwa na response. Ina maana response ndo yale majibu sasa yatakayokuwa yanajeneretiwa na model, na kunakuwa na source. Source ni kuonesha yale majibu yametokea sehemu gani. Kwa hiyo ndo hizo data zako unatakiwa uziandae kwa mpangilio huo. Sasa the problem is, utawezaje kusoma dokumenti zako? Kwa mfano sisi tulikuwa tuna document 30. Utawezaje kusoma document kama ile katiba ukajenerate maswali kutoka kwenye katiba mpaka ukapata kwamba hili ni swali, hii inaweza ikawa ni response tosha, na hii ni source yake. Kwa hiyo kwenye fanya fine tuning, the problem is data preparation. Kwa hiyo hilo ndo lilotuface, ila tumeweza kutumia tena knowledge of AI ili kuweza kujenerate hayo maswali. Kwa mfano sisi kwa kuwa tunaelewa, tuli upload some of documents kwenye GPT, afu tukawa tuna command GPT atupe kitu tunacho kihitaji. Data ni kama hizo. Kwa hiyo ndo data zetu tuliziandaa kwa namna hii, kwamba tulikuwa tuna prompt how many articles are there in the Constitution of Tanzania.
Sorry. Thanks.
Kwa hiyo ni kama hivyo data tulivyokuwa tunaziprepare, na tulitumia document moja ya Constitution of Tanzania, na bado tunaendelea kujenerate maswali kupitia documents nyingine ambazo tunazo. Kwa hiyo cha kwanza ni hizo, cha pili ni je, hizo data unazipata wapi kulingana na problem unayotaka kuisolve. Mfano sisi data nyingi tulichukua kwenye Tanzli. Tanzli ni website za mahakama ya Tanzania, kwamba kuna kesi zimesolviwa, walivyomaliza kuzisolve wana upload kule majibu yake, au kwa mfano kuna laws zinafanyiwa amendments, wanaenda wanaandika kule kwenye gazeti. Kwa hiyo ndo data tuliziprepare hivyo, na of course tulitumia knowledge tulionayo kwenye AI. Una prompt ChatGPT, anakuletea format unayohitaji wewe au format waliotumia kutengenezea maswali ya large language models husika unayotaka kutumia. Mwanzoni tulitumia ilikuwa inaitwa BELT, ila baadaye tukashift baada ya kuona alama 3.18 billion parameters inafanya kazi vizuri. Kwa hiyo ndo changamoto tuliyokutana nayo hiyo. Kwa hiyo the problem sana sana ni kwenye data preparations.
So I wanted us to get the experience from someone who is actually building something on what I'm trying to talk about. So kama una maswali zaidi, nadhani unaweza ukakutana na Onani akakuelezea zaidi. And so mko stage gani sasa hivi? Bado mnatengeneza maswali au mshaanza kufine tune?
Mimi nilikuwa natengeneza maswali na kuna mwingine alikuwa na environment ya fine tune bado. Most tume fine tune kwa mwanzoni ileta error kubwa, loss kwa like 98%. Na mpaka sasa hivi tumepata loss 80%. Tunaendelea kutengeneza maswali model na fine tune zile parameters like training rates, watches, itaalamu mara ngapi kwenye kusoma maswali. Kwa hiyo ndio tumefikia, tunatengeneza maswali na fine tune model. Mpaka sasa tuna maswali takriban 2800
Thank you so much, Onan, for that insightful description. Yeah, so nadhani utapata pia watu wa kutesti hapa. Nitajaribu nijaribu siku moja kujitetea, kutafuta sheria za kunitetea nikikosea. Yeah, tafuta vifungu vya sheria. Nasema hii ipo kifungu cha ngapi pale? A. Yeah, so that is the data preparation part, but the fine tuning is a supervised learning process, in the sense that you need to have labels, like it's like the sense of having labels and features, lakini kwa kesi ile tunakuwa na prompt na completion, like the prompt and response, and then wao wameongeza na source, like where the hiyo specific either response imekuwa referred wapi. So to put it into perspective, kwa mfano hapa, if you want to train a large language model, fine tune kwenye program labda unataka ifanye sentiment analysis, so utakuwa na reviews kama hapa. Tuna review ya kwanza, like tumesema this is a review, hiyo ni instruction, and then classify this review, that is an instruction, and then tumeweka review yenyewe, alafu tumeweka sentiment kwamba ni positive, then tukaweka like the review ya pili, alafu na sentiment yake. So from there, then from the prompt pair completion, unakuwa una pre-train a certain, una fine tune a certain large language model specifically on instructions, and there unakuja kupata ni small instruction model. So kwenye kutengeneza data specifically alikuwa anaongelea Onani, kuna different templates you can use. Kwa mfano yao ilikuwa, kwa sababu ni question answering, that was the template actually. Kwa kama unafanya sentiment analysis, unaweza kuwa na different template ya kuprepare data. I don't know if they're very much visible. Kama ni kwa text generation, au kama ni kufanya summarization, pia inaweza ikawa na different format. Yeah, kwa hiyo utakuwa na pre-trained model, and then you do fine-tuning process, then you get instruct model or fine-tuned model. And that is full fine-tuning. So when you do full fine-tuning, that means you adjust all the parameters in a model. So you do adjustment of all the weights in that specific model. You are fine-tuning. And when you do full fine-tuning, like adjusting all the parameters in a model to align to what you are trying to solve or to your specific problem, it might cause some issues. Specifically, it can lead to the model can forget the other knowledge it had. Kwa hiyo wanalifaa kama catastrophic forgetting. Like labda model imekuwa trained kwenye like a large of data na ina a lot of knowledge about different aspects, lakini ukaamua kuifine tune kwenye finance data peke yake, manake kuna high chance ya ku lose all the other knowledge ambayo ilikuwa nayo, like the other knowledge that it had before. So that is the disadvantage, I can say, of full fine tuning. So one of the approach to avoid that catastrophic forgetting is to use parameter efficient fine tuning. Like you can do like different three things. The first one, you might not have to avoid that, because for instance, if you want to create a large language model from the existing open source models to solve like the case which they are solving of law or the finance case, you might not need to think of that the model is going to lose other information because your focus is finance or law. But you might need to fine tune it into multiple tasks if you want it to retain the other knowledge, so you can have the correction of other knowledge you want it to have. But also you can do parameter efficient fine tuning. So parameter efficient fine tuning is just, in simple terms, I'm going to explain in details. mostly you have a model and then you fine tune a portion of its parameters. Like you don't do a full fine tuning, like you update some few model parameters. And to do that, you need like this is the concept now of what is being done on the parameter efficient fine tuning. So first we are showing the problem with full fine tuning. So the problem with full fine tuning is still the same like the computation. So you need much computation as you are going to update all the model parameters. And to deal with parameter efficient fine tuning, you just update, or you can do like you can do the three, I think, I don't know if I've highlighted them here. No, but there are like 3 or 2 options if I remember well. The first one, you can freeze some of the weights as I shown here on that specific large language model. Like you keep them constant, like you don't change them, and you change some portion, or you change some portion of parameters, or you add new layer with new parameters which are going to fine tune those specific parameters. So you have the large language model, and then you have the new layer of trainable parameters, and then you have the frozen weights. And by doing so, you can end up fine tuning on a small layer. So if you like, let's say when you do full fine tuning, when the model is having, let's say, X GBs, when you fine tune it to QA, like Q&A task, you're going to deal with those X GBs. And when you are dealing with large language model and you do full fine tuning on any other task, you're going to deal with the actual size of the model actually. But when you do parameter efficient fine tuning, you're actually going to deal with some few like a very small size of the either layer you have added, the trainable layer, which is going to have some very few number of parameters. Then you're going to fine tune them. So you are going to have a very large model, and then you freeze the parameters, like the model parameters. Then you add the trainable layer, and then you train it. So to do that parameter efficient fine tuning, we have different methods. So the first one is selective. Selective is where you, from the parameters of the model itself, you select a certain portion of the parameters where you can do fine tuning. But also we have additive. So additive is you can just like add an additional layer to do fine tuning. But also we have the parameterization, and that's what I'm going to talk about. Okay, let me see. There's some people want to join here. Yeah, so I'm going to finalize this, and then we are going to I think to end it here for this time. So one of the techniques that is being used to do fine tuning is the parameterization with low rank representation or low rank matrices. So the idea is you have a large language model, and then you add some matrices, I can say, or some trainable parameters, and then you train the parameters together with the model itself. To put it into perspective, it's like this one. So you have the large language model, like you freeze most of the original weights of the model, and then you inject those matrices, the rank recomposition matrices. So I think this is not going to be a very technical session. And then you train that small matrices you have added to that model. Like you don't deal with the with the weights or the original weights of the model. Instead, you deal with the matrices you have added or the trainable parameters you have added as a layer on that specific large language model. And then you train it. And then on inference, after training it, actually, to do inference, like when you want to get response from that specific model, you're going to use the original weights and the LoRa weight or the low rank adapter weights to get the response. Yeah, so there is a hands-on here, but today is not a hands-on day. But I want us to talk about something here, then we're going to finalize this session. So what about human values? So do we know human values? What are human values first, before we go far? Can we share human values? What are our values? I see there's no human here. What are human values? I think we have them in our thoughts. When we leave them, possibly always. Yeah, so one of them, I don't know if it's a value or it's just a statement, like to treat everyone equally, like as human. I don't know if it's a value. So to put it, I will put it this way. So humans have different values, or we have different interests. So for instance, Tanzanians and Kenyans might, regardless, we are all Africans, but we define some of values we live in. Or even when you consider the even tribes, I think, so you might find a certain ethnic group, they have their own values, and a certain other ethnic group, they have their own values, and they differ. So these large language models are being trained outside the environment or outside our context. So, and mostly the data that is being used, the higher representation is not of us or not of Africa, let's say. So how do we make sure that the values of either Africans or the values of a certain group of people is being preserved in those models? So that's where it comes on the problem of human value alignment or value alignment problem or alignment problem issue. So alignment problem is when we think of how we can align the AI systems or the AI models to align with human interests or human goals. And to solve that, one of the techniques that has been currently used is reinforcement learning from human feedback or from human preference. And that's going to be a session tomorrow. If you have seen tomorrow's session, we're going to have that reinforcement learning from human feedback. So I'm not going to talk about it here, but I was just trying to trigger a thought on that. Yeah, so I've tried a bit to explore some of the LLM concepts. So there are other concepts like retrieval augmented generation. So we have a session tomorrow about notes, actually not tomorrow, the last day on Saturday, about retrieval augmented generation and the intelligent agents. So I think you'll be there to learn more. But for now, let's end here. I welcome questions specifically on large language model and generative AI. From the remote host, if you can hear us, you can just write your questions, or you can ask key direct. Hello.
We
Yeah,
have a question.
Someone shared also we can use, though not free, we can use cloud computing to train models. Yeah, that's very correct. So I think it's not free, but it has like it's somehow affordable compared to training a large language model from scratch. Yeah. Yeah. Someone was asking question. Actually, can you proceed? Hello.
No, we don't have a question from Nelson Andre.
Okay. Thank you so much. Yeah, here. Yeah, so if there is no question, here at the venue we are breaking for lunch, then we'll be back at 3. Yeah, so there is a question here, sorry. Yep.
I want to know, nilisikia that OpenAI engineers walikuwa wanashia wakasema kwamba walikuwa na training model ijibu maswali kwa English, but the Africans kujibu kwa lugha nyingine and they don't know why. So ilikuwa
Actually, I haven't heard about that kwa OpenAI, ila nimewahi kusikia Facebook zamani kama mwaka 2000 na kama sio 2020 ilikuwa ni 2021, 2019. Ndo nilisikia Facebook they had that case like 2 models started to do conversation in different language, like in the language which wasn't actually expected, and they had to shut them down. But for OpenAI, actually, I don't have any details like about that or even technical explanation. And one of the cases, most of the models which are being trained on the basis of artificial neural networks, most of the time it's hard to explain why they are doing what they are doing. So and I think it's still a problem people are trying to solve regardless of the existing techniques to try to make them explainable. But it's sometimes still hard to explain. That's why we have these emergent properties. So emergent properties are the properties of large language models that emerge, or like they emerge unexpectedly. So it's like you see the model starts to behave in a certain way. It might be a very good way, like an unexpected property that is very amazing. So it might also, we might also have the bad emergent properties also, but most of the time we encounter them, or they encounter them when they are trying to either to do inference. You find like it can do this or it can do that, and you didn't expect it could do. Yeah, but I can't explain more on that specific case. Thank you so much.
Thank you for the very good presentation. My question is, why would one use an open source LLM over a closed one? Like, why would one use like Llama 3.2 over GPT-4? Especially when developing products to go to the market for research.
Thank you so much, Doctor, for the nice question. So, as per my understanding, across the models, the proprietary ones, I think I don't know if you want to fine tune. I'm not sure if OpenAI released the like weight of the model. I think I don't remember well if they released it weight. I think it was GPT-3 or GPT-3 possibly. So if you want to fine tune and it's going to be very hard actually to use proprietary models because you're going to need the model weights. And most of the cases, they don't open source the weights. But if you want to build another solution that is that can use API actually, maybe you can opt for proprietary models because they do well, like they are good. So you can consider them because of their performance or their ability to handle the different cases or to perform. So that's the reason for you to choose depending on what you want to solve. And for instance, with Llama 2, I think initially they were open sourcing the weights, but they were limiting them to mostly research purpose. But then they changed the license. I think now people can do even some of the business or products, if I'm not mistaken. So you can consider open source models when you want to work on the model weights, like to fine tune the model, and maybe you don't have enough, let's say, maybe enough money or enough fund to invest on training from scratch. But to be specific, you can choose open source models because at the end of the day, also you can have data ownership because you'll be having either you will fine tune and then you're going to remain with the weights, or you can deploy it on your own servers or your own systems, and you can be sure that your data are secure when you think of it in terms of data protection. And for the case of using proprietary, we are not sure. For instance, if you're using an API and you connect it with your data, I don't know the agreements. I haven't read actually the terms and condition, but in most of the case, you find like you have to agree they can use also your data to train their coming models. But also, I think you can disagree. That's my understanding so far. But if anyone also has anything to add on that, because this is the discussion, anyone can share and help us to learn more. Yeah, thank you, madam. So if you have any question or addition, you can add to. Yeah, so if no, then we are going to take a break. I will be back at 3 p.m. Thank you. Hello? Hello? Hello?
We can hear you from here.
Okay, so we are back for the last session actually. Yeah, in the last session, we're going to talk about retrieve augmented generation, just in a nutshell, because we are going to have a workshop on this topic. Yeah. Yeah, so what is retrieval augmented generation, or why we need retrieval augmented generation, or what is it? Yeah, so I shared earlier kwamba baseline LLM or base language model foundational models, kwa mfano Rama 2 now Rama 3 or 54, they only have information that they've been trained on, and they can't access, or they will just see for short when we require them to know information beyond that period of time that they've been trained. And sorry. Yeah, so okay. So, yeah, and because they can't access the most recent or information beyond that period of time, we have to use a different technique to make them able to access the most recent information. And to do that, we use retrieval augmented generation. Though currently these large language models actually they can use tools. So tools, maybe we know, maybe we tell a large language model to do arithmetic, which sometimes they can do well. For instance, multiplication of large numbers. So what we do, we can have a calculator as a tool, and then when it is required to do arithmetic, it just calls the tool. So we can have a calculator, browser. So when it has to browse something on the internet, it just calls the browser, and then it browses for the recent information. So and here is the big picture of what happens.
Sorry to interrupt.
Yes.
Sorry to interrupt. Your voice is very low. We cannot hear you clearly.
Hello. Can you hear me now?
Can you come close to the mic? We cannot hear you clearly.
Hello. Hello.
We are struggling to hear you. Sorry.
Okay.
Yeah, maybe come close to the microphone, or maybe just increase your voice.
Yeah. So can you hear me? Hello. Hello. What should I do?
I think now it's okay.
Okay. Yeah. So I was saying, like, as we know, large language models can't access the most recent information or the private data. As I shared earlier, maybe I have my organization and I want to to train a large, like to fine tune or to use LLM to solve my business case. That means I have to provide it with my data. So to do that, here is the big picture of what happens actually when you are building a retrieval augmented generation application. So the first thing, as you can see in this short flow of the application or the RAG system, is that you have a user input, and then that user input is being sent to the vector store. So I'm going to talk about the vector store, what is it and how it works. So, and then from the vector store, we retrieve the most relevant information from the vector database, and then we take those, retrieve the information, we send them to the large language model together with the user input. So we submit to the large language model the user input and the relevant information we have retrieved from the vector database. So LLM now has a task to complete or to create a response based on what has been obtained from the vector database and the user question. From there, we create the response so that we can respond to the user. That's a very simple flow of how it works. So, but we need to understand the very important aspect, and that is vector database. Let's do this first. Okay, I have to make them. Yeah, so we have to understand the vector store or vector database, what is it and how it works. So there is another flow chart. As we proceed, we are going to understand well. But to do that, or to create a retrieval augmented generation application, you need some tools, and these are some of them. The first one is LangChain. So LangChain is just a tool for creating or automating some tasks when working with large language models. Same to Emai. Previously, it was known as GPT Index. So you can opt to use LangChain or GPT Index, or you also you need. I just put there OpenAI API, but actually you can use any open source large language model or any API to large language model. But also I've mentioned there Gradio. Gradio is just a tool for creating interfaces. And if you want to create just a simple prototype to share with people of what you have built, you can just opt to use Gradio for simple interfaces. And as I said, LangChain is just a library to streamline the interaction with large language model. For instance, OpenAI or the other. But also it supports other open source large language models. So you can use it with Llama 3, or you can use Ollama actually with LangChain to access large language models. And Llama Index, previously known as GPT Index, is also a framework. In some ways, you can opt either to use LangChain or Llama Index for the same task of interacting with large language models. Actually, I won't talk much about the differences or which one you should use at what time. But one of the common thing between these two tools is that they are not, they are very dynamic. So they change frequently, like the functionalities or the function names, and maybe the attributes. You find like they are very changing. So you need to keep yourself updated on the new ways of either calling functions or the function names and all that. And the other is the large language model. For this case, I just mentioned OpenAI API because for those who are building, let's say, application on top of OpenAI, you just need access to OpenAI API, but you can use Ollama to access open source large language model like Llama 3 or Mistral or other open source large language models. And as I said, Gradio is just a an open source library for creating user interfaces. So there's not much to talk about it. So you can create currently, like you can create interfaces for multimodality, interfaces for chatbots, and other kind of interfaces. Yeah, so if you want APIs for OpenAI, you can just go to this URL. Here's the other flow chart, which actually I'm going to explain now what is the vector database and how it works. So as you can see, we have the PDF documents like there, and then we read the documents, or we load the documents from the source if it's a drive, and then we have llama index. At the point of llama index, we can have LangChain also. As like we have LangChain there, we have llama index, but you can use at the same time LangChain or llama index at both parties. So after loading the document, we what we do is we create a vector database. So I think, let me see here. Okay, so I have to do something. Yeah, so this one. Yeah, so we lead documents, and then we do vector indexing, and then we go to, like, step 2 is vector indexing, and step 3 is creating an embedding model, and then we go to constructing a vector database. So what it happens is we load the document, and then we can separate it into chunks. So chunks is just like, for instance, let's say I'm having, let's say, a document of 100 pages. So I might decide maybe to chunk it into single pages, or maybe a single page, and then I just divide it into 2 chunks. So it's just like you just put chunks of that specific documents, and then you use large language model. For instance, there an OpenAI large language model, that is a model for text embedding. So what that mean is, you take your PDF, you do either chunking or you put it into pieces, and then you use large language model to do embedding. So what is embedding? Embedding is just a technique to transform your text data or PDF data into certain numbers or certain matrices or vectors, so like which represent actually what is in the text. It's like, because to put it in a simple way, it's like, because we are dealing with text and we can't process text, so we have to transform them into numbers, certain set of numbers, like the meaning of numbers in terms of LLM, so that we can use the numbers instead of text. And those numbers or those matrices are referred as embeddings. So after creating the embeddings, we store them in a specific key store. And that store is called vector store or vector database. So that's the process of processing the documents. Like, you have the document, you load it, you do either chunking or something, and then you do embedding, and then you store it. As we know, for normal database, we use to store, either we can store data into these relational databases, or we can do with NoSQL, like the MongoDB, like in JSON format. But currently, we can store data in terms of numbers or vectors. Like, you have your PDF documents, they're being encoded into numbers, and they're being stored into a vector database or a vector store. So when we want to find something, we use search. Like, we can do semantic search. Like, maybe I do a query, maybe I have a document, a PDF about maybe my profile, and then I ask, like, what is like I ask the large language, maybe what is the education background of Zephaniah. So it's going to the vector database, it searches the relevant numbers in this case, then it decodes back the numbers into text. So to decode back the numbers into text to respond to me, that's where again we need the large language model to help us construct the response, which is the next step I'm going to talk about. So I hope we are all okay with the process of embedding the document. Like you have the PDFs and then you change them into embeddings or vectors. And here is the second step. Sorry. So the second step is now we have integrated with the user flow. So we have the vector store there. Like it is storing our vectors or our embeddings, which we have encoded from the PDF files or any kind of files, might be PDF, CSV, or any kind of other type of document, but it has been encoded into vector database, and then we have stored the number there. Then the user asks a question. Like as at step one, you can see the step one, ask a question. So when the user asks question, then we go to step two. Step two, we are taking the question and we go to search for relevant information regarding what user has asked. And to do that, you can use different techniques for similarity search. So we can use constant similarity, or maybe Euclidean distance, or you can use also even Manhattan, or they refer it as L1 distance. So you search for the relevant information concerning the question user has asked. And then when you get the information, you go to step three, forward the request with the LLM via LangChain. So you take the user request and the relevant information you have retrieved, that's where retrieval comes out. You have retrieved it from the vector database, you send them to the large language model, and then the large language model is going to construct a response based on what user has asked and what has been retrieved from the information or from the documents. So if I asked about my education background, and for instance, I used my CV document, so maybe in my CV, I just highlighted their education, Bachelor of Science in Telecommunications, let's say. So when you are doing vector search, it's going to find like something maybe like telecommunications with no clear explanation of what happened. Like it's going to match with something like that. And then it sends that relevant information like telecom, and then the large language model is what is going to construct the whole response from the single or the retrieved information. Like the information that has been sent is just telecom, and then the large language model, because it is capable of generating like long text, so it's going to use that. So it's going to create like your Zephaniah Rubeni has background in telecommunication, and this is like it's going to create a more natural response from the information which has been retrieved from my CV. So that's how it works with retrieval augmented generation or knowledge-based systems. So even if it is in your any workflow, if it's a company or what you want to have that automated process to either save customers, so you take maybe a bunch of questions which mostly like the most frequent asked questions, you do RAG, and then when the customer comes and asks, what do you do? Like, what do you do at your company? The chatbot is going to respond because it can retrieve information from the documents and then construct a more humanly response. So that's how it works in a nutshell. So for instance, that's not visible actually. So this was a system I created. I will show you something actually. I don't know if it still exists in this computer. Like, so in some days I just took a book, like it was artificial intelligence book, and then I did write on that book. Then I was trying to ask questions based on the book, then it was able to give responses. And this UI is actually the UI, which has been created using Gradio. So some of you might be familiar. I will just show you here. Let me go to Gradio. Yeah, so when you're working with Gradio, actually you can find different interfaces. For instance, let's see here. I want to see interface samples. You can see them here. Okay. Yeah, so here the sample interface, let's see. Yeah, so for instance, here is just a Gradio interface for uploading an image. You just need to write very simple, like very few lines of code here, and then you get an interface like this. It's mostly used for prototyping. So if you have your own AI application and you want to do a very quick prototyping, you can just opt to use Gradio instead of working on the full user interface scripts.
I think the remote people can't say.
Oh yeah, I didn't share it, yeah. Okay, let's see. Yep. Yeah, so I was sharing about Gradio. So it has a lot of other useful features and the interfaces, so you can just explore them. For instance, here we have a multimodal chatbot interface. So you can see, like you can have input, like a pictures and input, and then you can input audio and video also. So like, and then they show how you can just create that simple UI by just installing. People install Gradio multimodal chatbot, and then you write very simple scripts here. Then you're good to go with that, like a prototyping interface for users to try your application. Yeah, so let's finalize here. Yeah, so there was an hands-on. There is a hands-on there, but we won't be doing it today. Yeah, so there is some references here, links. I think because I share this slide, so we'll be able to access them. So let's discuss about the what are the local use cases of large language models. So we had in the morning that led who was representing the National Museum, spoke about how AI can help them to simplify or automate their process of handling clients here. And we had one idea, like maybe when you go to lead there, or you want to get more explanation about a certain thing there, you don't need a person. You find there a tool that can explain to you about that specific thing, and you can ask a question, like you can do conversation without needing any other person to help you with that. So that's one use case of large language models. So what are others we might think and we can use the available, as we said, the available open source infrastructures or open source foundation models to build or to solve the problems we see. So we can discuss a bit on this. I think then we will be ending the session possibly. So karibuni. Tunaweza kusolve nini? Watu wa online pia, you can share your thought. What are the LLM's local use cases? Yes, Henry, you're welcome. Yeah, so customer services, that's the one of the use case. And I think Karibu is here and he's doing well with using LLM and specifically the knowledge-based LLM in handling customers using the Sarufi chatbots. So that's one of the use case. Yeah. Any other use case? Tunasoma vitu ambavyo hatuwezi kuvitumia kusolve matatizo au matatizo hayapo. Matatizo yapo yako wapi sasa? Matatizo yako wapi? Yes, you are welcome. Yeah. Malizia and then Karibu will share a bit. Utajua hivyo hivyo. Usishtuke. You're welcome. LLMs in healthcare, right? Like to do what? Can you explain a bit? Okay, diagnose patients. So it's like maybe in conversation words, right? Oh, maybe I say, maybe I feel this, and it can say, maybe you can do this, something like that. Because in some of the disease, maybe it's mostly you need to pass through a lot of processes to go to lab to test and everything. Yeah. So Kariba was talking about the local use cases of LLMs, and Henry said that they can be used in customer services. And then we talked about how Sarufi chatbots are being actually built on LLMs and knowledge-based LLM to serve customers. So we think it could be better to share a bit on that. Yeah. Kuna watu huko online pia. Yeah. I think hiyo watakusikia tu. Maana ukiweka microphone hawanisikii.
Yeah. So mimi I'll be both positive and negative on LLMs. Yeah, so I mean we use it a lot, like on Sarufi, people can make a chatbot, they can upload their knowledge base and then they can add some prompting, temperature, and make a bot. But also we'll listen to the launch Gala. So Gala, we're not using any intent, it's pure LLMs underneath. We're not saying any AI stuff, but actually we're using a lot of zero-shot LLMs to understand what people are doing at there. Do they want to shop? Do they want to ask a question about something? Yeah. So we're using that to power those social commerce experience. But we did roll out LLM some point in time as a marine, our client. And we had some issues. We didn't tell any LLMs about Malipo. And some people keep asking, come, okay, how do I pay using M-Pesa? So LLMs answered back, you can pay using this and made up every like control number, lipa number, fake lipa number and everything. We had 2 people who actually paid. You see, it's very like random. Like I never prompted anyway. There's this knowledge base about kulipa as nini. Yeah, and then we had serious people paid on random Lipa numbers, NMB and whatever. And I had to shut it down for a while. So I think as much as it's good, I think it depends. If you're not involving numbers, I mean, that you can like, it depends. Because maybe I never thought, because I'm like, okay, we're not involving any crazy stuff. It's gonna be fine. But that was unforeseen. Yeah. It's gonna promise people, give people, it's gonna mislead people how to pay. Yeah, so I think it need to be balanced. Or if you do it for client, you need to really balance the guardrail, like make sure it doesn't go wrong. We had another client, it made a good bot, apparently like a good knowledge base, but there's some numbers, never like figures. Okay, this is the price and this is what. So as people answer, sometimes LLMs tend up to make stuff up. I used to underestimate it. You ask the first time, it's okay. Second time, it's okay. Third times, you have a random number, and that is very risk high because you promise something people. So I think the use case is very huge, but you must apply kwanza it on an area ambayo the risk of misinformation is not high. Okay, if you mislead someone, it's okay. And it's okay, and it's not a big deal. But if you apply somewhere ambayo there's gonna be data involved, you need to be very controlled environment. That's what I realized. Put temperature to 0, but still they might hallucinate sometime. Yeah. So I think as much as you wanna do it for real use case, you need to keep that in mind. They can really go rogue, and you need proper guardrail. Like if you be just like a basic rag and put it to client and put in some crazy prompting, you don't answer this, it keep answering at some point on production. Anyway, I think we need just a proper way to use. But I think it's high potential because sometimes it used to be very hard. Like say with Gala, right? We want to know if someone is trying to buy something, we need to know they're trying to buy something. The old way is use training and entity cognition models, never. And if someone says, you need to know, okay, there's an entity, then I need to search this product. But with LLMs, it's just, I have one zero-shot classifier. It can know, this someone is trying to make an order, right? It can extract those entities automatically, telling, okay, this someone is trying to ask a question about this. This someone is trying to cancel. So it's easier to really control the flow and automate the process. And sometimes you can make it fully LLMs. Yeah. So I think that's my bit of view on how we use LLM. Yeah.
Thank you so much, Karen.
Yeah. In your case, what about prompt injection?
Yeah. I mean, prompt injection, basically, it comes from smart people and it's risky of your worry, usually. Because smart people will come to your bot and say, they want to just test it, okay, can it do this? Because most of the time, you don't like put sensitive data on LLMs, right? You want to put a controlled data. If it's controlled data, you authenticate it. So we have a client called Adam Kononi. They have a chatbot of which is linked to their system database, right? But the way we're not fetching everything from database. So you can't go there and prompt it, fetch me all of the records of customers. You can't do that because your WhatsApp number is your authentication, right? So if it's coming from this WhatsApp number, it's going to fetch only your data. So if you're prompt injecting your own data. So that should be the least of your worry. Most of your worry should be like it could go wrong sometimes, really. And those time you don't plan for it, and sometimes you cannot foresee it. Like you never train LLMs with payment or anything else. It made up Lipa number, like validate, tell people go to Nyota, me, I'm seeing it. It was unbelievable. I'm like, what? How this is happening? And proper Lipa number, like 6 digits, 444. But it doesn't tell you. It tells you, okay, you ask, okay, should I pay this? You tell, yes, go pay this. So it's like you need to be a controlled environment around your LLMs. I think as much as time goes on, maybe you might find more guardrails. Yeah, but I used to believe if you do proper prompting, put temperature to 0, that's it. But no, you should put, I think, more guardrails to make sure it's very controlled. But if something is not, like the nature of the data is not sensitive, it's not like if the chance that LLM give you a slight wrong answer, the risk that if it's small, then LLM is good for that. It can just work well if you just normal information. But if you're trying to do something which something goes wrong a bit, it's very high risk. Like someone end up paying a random shop, and you need to be calling them like, no, that money was meant for us. Yeah, so I think that was my view. And right now I'm kind of in the middle. I like them, but I need to make sure I'm okay. Can it really? Am I confident that if it goes live, it won't answer something I don't expect? Yeah.
Yeah. So I think we've had this conversation before with chatbots, and the last time we talked, I think I met a person doing a chatbot without AI 2 months before we take about the AI part chatbot. So it was very unfortunate. But then now it makes me more curious of more of I'm worried. We want to venture into AI, and I think we've had this conversation as well. The whole compliance space is something we're really targeting. There's a compliance startup. Now, should this guardrail? I'm not really into the back end of the AI stuff much, but is it safe to say that it's possible to because I can imagine someone issuing a receipt from our end, and then you add 1 0 and the catastrophe there with the CRA is going to go crazy. So should we be worried? Is it safe to say that there is something you at least can do? Because I think you're probably leading that side here in Tanzania. Maybe others are doing it, but not as loudly as you are. Is it safe to say we can get around it?
Yeah, definitely. But I think you should think about going full LLM. You know what I'm saying? So Sisi, if you ever see leo launch bot here, bus ticketing, Azam ticketing, the only AI part is a very small part. Basically, is basically intent. What intent you follow in, and when you know you want to do this, the whole flow is predetermined because some of the action are known, right? You want to issue a receipt, either this step and this step and this step. So in that way, it's predictable. You know what it's gonna do. You won't be worried about any surprises, right? But the moment you say, okay, I want to use LLM, I want to use function calling, it's full LLM. LLM will collect all the data, will give me, and then I'll submit it. So I think that's the risk part, because it needs now to be controlled, because anything goes wrong, it might be wrong information I'm putting into the system. So I think if, let's say, issue receipt, why should you use LLM? You can use LLM to do FAQ, right? You have your own question from, okay, this is our policy, this is our charges, this is what and what. But you say, okay, on that action of issuing receipt, no LLM is involved. If you want to use full LLMs, you gotta be careful. But the guardrails are there, there's guardrail framework are there, and there's people building this guardrail, so it's possible, but sometimes it's not out of the box. When people are making a solution like an app, cybersecurity is like the second they think. Okay, I make an app once it goes live, and then when they hack me, I'll secure it, right? So I think it's the same thing with LLMs and AI. So I think even the cyber, I'm not. This prompting testing is underestimated. It seems like it's not a job, right? But I feel like it's prompt hacking. It could be something like a career, because before you go live, you need to make sure, is my LLM safe? Can it not go wrong? So I think it's like in the cyberspace now in terms of AI. So I think it need to be somehow prioritized on your release cycle. Before you go live, give it some people to find a way it can answer something wrong, and then try to fix it. And then when you are sure it beat it, okay, now at least the response are predictable and what we expected, then you can say, okay, now let's go live here. Yes, thank you.
Another question? Thank you so much, Khaled.
Yeah.
That was nice. Yeah, so I think also comes the case, the question you asked Dr. Dean about using open source and cross the source. It comes also as the sensitivity of data actually you're trying to use matters also. Yeah. Thank you so much, Caleb. So I've just remembered we were working on something. Like we are creating a tool to help Swahili learners to learn Swahili very easier. And we created this, we were calling it Kamusi, but then we changed because we feel like it's going to expand to more other features apart from only maybe defining terms. So let me share. It's like we have questions, so. Okay. Oh yeah, thank you so much, Vladimir, for the inputs here. So Vladimir says one of the use cases is to use LLM to generate codes for the projects, which saves time. Like to go to the documentation, instead you can just use large language models to help you with coding tasks. And I was going to share here about, we call it locus currently. So this is still at the development, like it's more of testing phase. So what is locus? Locus is just a simple app to help you understand Swahili words and their meaning, but also how they can be used in different sentences. And the idea was, first was to create like like Swahili dictionary. Like when you enter like a Swahili words, it's going to tell it what does it mean, the part of speech, how can it be used. And then we found like there are people who are not speaking Swahili and they want to learn Swahili from it. So we thought of making it like adding something like we have kamusi to give meanings of words, like not the direct translation, but to give meanings of words, but also the other parties to give like translation, maybe from Swahili to English or English to Swahili. As you can see, most of the time, the Google translator sometimes misbehaves, specifically in Swahili. So we are trying to come up with the solution that's built from Swahili speakers, actually. So, so what it can do currently is to give you the meaning of words. For instance, I can ask maybe mama, and then I can submit here. Yeah, so what we did first initially was it was having only Swahili like this. So unataka kufahamu neno gani? And then you enter the word. For instance, here we entered mama. So it's going to say mzazi wa kike wa mtoto au watoto. Hiyo ni maana ya kwanza. Maana ya pili, mwanamke ambaye anahusika na malezi na ustawi wa mtoto au watoto. Alafu collapse like expand this one, itakuletea aina ya neno ni nomino, and then visawe ni kama synonyms zile. Kwa hiyo itasema mama mzazi, mama mkubwa, mama mdogo, afu itakupatia na kuna maneno mengine naleta na namna ambavyo like how you can use the words, like the example usage of the words. So and then we sent it to someone actually yuko nje ya Tanzania, and then he wasn't able to understand what it does because the interface was all Swahili. So we added like this translation for the people who are learning Swahili, like who are outside the country. They want to understand like the meaning of words, so like Swahili words. So they can, like for instance, when they enter mama, as you can see now the response, you enter their mama, but the response still comes in Swahili, like you see meaning one, mzazi wa kike. So if someone is learning Swahili, it's still going to be a problem for that person to understand again the sentence. So that's why we are working on making it more, because it was more of a testing application, and we got some people actually outside Tanzania. And as we know, currently Swahili is one of the language, actually the second language for like AU has passed this as the second language to be used specifically in Africa. And there are a lot of people who are trying to learn the language outside Tanzania, even outside Africa. So got people interested to use it to learn Swahili, but we have to improve it to be very friendly and supportive based on what kind of people are coming to learn there. So we are currently working on improving it, and we welcome inputs and suggestions of what you think is going to be a very good application for someone to learn Swahili first. And the features I've talked about, like the feature of translation, like to do dialect translation. For instance, maybe I want just to know mama in English, or in Swahili, like someone likes mother, and then mama, like no need of saying mother is someone. So that's what we have been able to build with LLM, specifically the open source models. So what we did, we actually tried to create some of the, as I shared about quality data. So we created some of the books. I think we shared some links, and we got very good resources for Swahili. That's what we used to create this. So we welcome inputs. Yeah. Yes.
As you say, you've got very good resources.
It's more Swahili books, like we Swahili books, yeah, it's more
So
Swahili.
normally, if you buy books and copy that, what are you?
So the issue is the issue comes the issue comes there. Yeah, that's very fine. That's where problems come. So that's why, as I'm sharing this my experience, we didn't share the link public because of that. So I just shared to some of my few friends, like, hey, can you
If you want to go live, you know,
I don't know actually. It's like you just build and then you find the path on the path ahead. Yeah, but we did that actually. Yeah, so maybe you can have advice or input or what you should do next to make it better.
What
Yeah.
was the development, like the pipeline? You use RAG or?
Yeah, so we fine-tuned the 8B Llama 3. Yeah. Yeah, the Llama 3 model. Yeah.
This was the knowledge base.
Yeah, so the knowledge base was those books. So we just extracted we extracted the text from the books, and then we formatted them, and then we did fine tune. Yeah.
So no RAG.
No. Yeah. But we are thinking of doing it because there are some people advised us to take the Kamusi and use it as a RAG resource. Yeah, so we were.
Now you know how to go live.
Yeah, so yeah.
I'm doing something similar,
Mm.
like farm advisory with poultry farmers. Now I have that knowledge base. How do you advise the farmer? The types of diseases, poultry diseases. But I got the software books. How do I go live?
Let me share something. I don't know if it's okay.
Go live and deal with it when it comes.
For instance, yeah, I want to say that. I wanted to share that actually. That's what I was going to talk about actually. Yeah. Yeah.
How do you deal with cooperative work? You come back with the authors, how at some point I mean you have because of their work, right?
Yeah. Yeah, maybe.
I mean, it's hard as well. But if you can just say that this is the source, that's what they want actually, right?
Yeah.
Because how many people write theses and researches that they don't even, sometimes
refer? Yeah, they don't do citation.
Those are not conventions.
Yeah.
Exactly. But anyway,
Yeah.
I think that's the only way. Just go out there.
I need a lawyer. I at this point I need a lawyer actually. Yeah, so guys, that was the discussion. I think Fred German is going to talk more on RAG and how to deal with agentic workflow on the Saturday's session. But for today, I think I had to share this because he's not here. And thank you so much. If there's questions from speakers at the remote venue, we welcome questions. Hello? Okay. Hello? Can you hear us? Or you hear us when we ask? Okay. Hello?
Yeah, we are hearing you, although the voice is not that much louder.
Okay, we are very sorry. I think we have to do something from tomorrow to make sure everything is okay.
Yeah, sure.
Yeah. So we were asking if there is questions from that side about what we are discussing on the use cases of large language models and what Caleb has said, also what I've shared here. Hello? Okay, I see a question here. Yeah, so the slides will be shared. I think today's slide will be shared after the today's sessions. So we're going to share them during the night, I think, and everyone will be able to access them. Yeah. Yeah, we're going to create a link. If you register, like if you registered into our registration form, you're going to get them via email actually. But we'll find another way. If you're in our WhatsApp channel, also we're going to share them on WhatsApp. Yeah. Okay. Thank you. Thank you so much, Bradley.
Okay.
Yes.
This is a quick question.
Yeah.
When you assess trends, technology, sorry if the blockchain or what you developers, but it's safe to say people are comparing AI monitoring results, and then we felt like AI will go down, but it's here to stay. It's so evident. I mean, if it goes away, I don't know but I fear that the leap into AI has missed the most crucial part of data, especially locally. Is that a weakness that we have? And maybe it's safe to say that we need to address, maybe people should take career into these data sets, especially when we're talking about Swahili. There's a lot of data that needs to be there.
Yeah.
So we still have, I think I heard of a project before with, I think it was a government institution, where they say they have a lot of paper and they want it to be into soft. So what wanatengeneza a platform ya hizo documents na zinapitisha zinakuwa parse zile zinawekwa kwenye my database or something. So it means we have not even gotten 100% or at least not even 50. I've not done research of kutoka karatasi kwenda into the software. So it means getting the software here is a problem.
Yeah.
It's clear that our pace technology-wise as a country is not that fast. So maybe customers don't really care if it's AI or not.
Yeah.
Something which is working.
Yeah.
But then the foundation of AI is data.
Yeah.
Is it safe to say that there's a weakness there locally? And like, how do we address it, especially in a platform like this? Maybe we need to say, guys, not only AI, but also data people.
Yeah. Thank you so much. First, I have to admit there is a big challenge when it comes to data locally from my own experience. So I've worked with like 3 projects, like for specifically in health sector, and it was very, very difficult to get data specific on those problems we were trying to solve. You might go to the hospital and then you find like there are systems where doctors have to be like filling the information, maybe the patient from the time anakuja mpaka ila anatoka, like the procedures maybe they have this like a standardized form, I don't know, like they have to take like maybe the previous medical history, social history, family history, and all to the final diagnosis. And then you find like there is age, name only, maybe age, name, and maybe final diagnosis. So you find like there is a lot of missing things. So that was that was a problem. But I don't know. In most cases, we talk about AI, but possibly most of people also don't know, like before you talk about AI, you have to talk about data. And for instance, when I was thinking to do this and to get Swahili, either Swahili books, someone directed me to meet Mkuki na Nyota and say like, go to Mkuki na Nyota, like the guy has a lot of Swahili books. And then, yes, there are a lot of Swahili books there. Are they soft copies? Or what are you going to do with them? Are you going to start taking pictures of books? Like you find like maybe data are there, but they're not in a suitable format to be used or to be used for AI applications. All data are there, but people owning them are not aware of how they can be used, or maybe they are aware, but they need also to get something for their lives. So they say, hey, to get this, you need to give us some cash. And sometimes they don't know, like maybe when they give you the data, you're going to build something useful for them, and it's going to simplify their whole operations and all that. So we might say maybe we lack awareness, but sometimes people are aware, but they don't care like that way. So kiukweli sijui nishauri solution gani, kwa sababu kuna mtu mmoja siku moja we were, if you remember Dr. Dina, in Daba X, the 2019 in Daba X, we were at UDOM, and then there was a panel, I think Dennis was there, Dennis, I don't know, Dennis Glory was moderating it. I think you were there, Pia. So before the conversation started, Dennis asked like, is there anyone here who's going to work on what we are going to talk, like, or like we are talking and then we go. So I feel like possibly if there was someone here to take action, I don't know if we are able to do that, like, hey guys, let's take action, let's find a way to make data accessible to researchers, to people who want to build local solutions. It's going to make sense. As I share, Nadani Innocent, I'm sharing, this is the story actually from Innocent and Certify. They were trying to collect data for like the tribes. Karibu nadhani utakuwa unakumbuka hii. And what happened? If you remember why they didn't continue, then you can ask yourself what happened. So someone called them like, hey, how are you? Like you are doing a good thing, like to correct like the local language data to create that dictionary is very okay. Yeah, that's very perfect. Who have given you the permit to do that? And I'm like, okay, yeah, you don't have permit, then don't do it. But I can give you permit for 6 million. You see? So that's very strange thing, but that's what is happening on the ground. And for me personally, I don't have any solution. Actually, maybe you can do this, but those are the problems we are living with. Maybe in the future, they're going to be solved. So you need to find some ways, like the shortcuts to do what you want, but ndo mambo ambayo yapo. Si kama nimejaribu kujibu kwa urefu, lakini yeah.
Yeah, but it's really a challenge.
Yeah.
Ever since it's tough, and when it comes to language, your ownership is so you're so far, I'm sure you deal by client on client, like specific use cases. You put that out.
Yeah, someone actually told me that. I shared the Kamusi in a certain group, and someone like, hey, you Bakita,
But that's where I really see where our Tanzania AI community will be very strong in this.
Yeah.
It's the Tanzania AI community. That's why we really have to all register with it and be members there. Tunafikisha hayo maswali because we really see our interface with serikali and what we really need to do as AI practitioners has to go through the community. Because so we really have to strengthen the Tanzania AI community because it's really our
I think Anna Gracie, you are taking note.
because we want to develop solutions in our local language and stuff like that. But I think it's just what start when it becomes a product. Yeah, because I work mainly with image data set, tunachukua images. Na kwa yani at times it's so intense, yani naishia kwenye data sets. My colleagues ndio wanaendelea na modeling. It's very intense. Most of the clients that I have in my company so far, the images data sets and culture. Kwa hiyo tunachukua photos, images za plants, plant leaves kwa ajili ya diagnose disease. So in a pipeline too, so it's like people write research projects to be funded to collect the data set. Well, here the project on its own, and it takes time. And then for you, it's like now what in the field, wako shambani, tunatengeneza zile tools and they collect the data using mobile apps. So they're in the field, like now we're collecting data on maize and beans. So we have people in the field. So I was contracted to this project to manage the data collection pipeline and the modeling stuff. But I have a team, there are people who are doing the modeling, I manage the data collection part. It's very intense because what work of field, when I collect data, you have to check kwamba zinakuja, okay? Alafu when they come, you have to do all that quality control, uzigawe in the different diseases, into the folders, make sure kwamba unaziarchive properly na nini, and they have their targets too. Very expensive. It's very expensive because for you, like it's an investment to be made. Yeah. Now for us, especially for language, tunatamani iwe I know Kenya collect a lot of data on Kiswahili. Wanaita Kiswahili Ken Corpus. Open source, lakini hiyo ilikuwa funded na Lacuna Fund. Iko there on open source. Sasa lakini niliongea na ile.
Hello, Erica.
Yes.
We are sorry, like someone is answering a question here, and actually it's being hard for you to hear specifically.
Pardon?
Like someone is answering a question here.
Yeah.
Yeah, it's like it's a Q&A time, so we are finalizing Q&A here.
Okay.
Yeah, so tunamalizia Q&A and then nadhani in the next 8 minutes tutakuwa tumemaliza for today.
So from our side, can we end up?
Nakuja kunini hapa. Nakuja kufinalize hapa in 5 seconds. I mean in 5 minutes chap. And then tatengeneza form takutumia hapo, right?
Okay.
Yeah.
Kwa hiyo 2 million downloads za hizo Kiswahili language za Kenya wanaenda sasa kudevelop products wenyewe wakiuzie. Ndio hizo unaona sasa hivi actually impact ipo. Sasa hivi Google Translate imemprove sana na Kiswahili.
Yeah.
Imemprove sana kuliko zamani. Kwa hiyo hizo open source zilizopo. Lakini unaona ilikuwa funded na Google Foundation. Lacuna Fund, lakini ilikuwa Google was one of the funders. Alafu unapewa condition iwe open source. 2 million downloads. Na sasa hivi ukiangalia Google Translate imemprove kweli Kiswahili.
Yeah.
Kwa hiyo yani it's advice media. Yeah. Kiswahili Kenya data set ziko pale 2 million, lakini how does Kenya benefit? Wale Waswahili wanaojua Kiswahili au benefit. Sasa kuna example moja nyingine ya kuna community nadhani ya New Zealand, Maori naona. Na wenyewe lakini sasa unaona the country has very strong policies na ila community wali contribute their language, umeona, kwa hawa researchers na nini, lakini in time lakini wakawa na very strong contract na terms kwamba anytime ile language inatumika au kampuni inatumia kwa ile language katika translation au customer care service na nini, wana amount ya hela wanapeleka to the community. Kwa hiyo inasaidia community services kwa wale wanao speak ile language. Kwa hiyo kuna hiyo system in New Zealand, kwa like the community gets back. Kwa unatamani hata Kenya hichi wale zile 2 million downloads ziwe valued money, kwamba community au ile baraza la Kiswahili la Kenya inapata some funding to continue developing the language na to retain. Sasa hiyo plan hapa sasa hivi ndio tunahangaika na AI strategy.
Yeah, so thank you so much. Yeah.
Unashindwa kushauri kwamba tuwe na community advocate, tuendeleze data set ya Kiswahili. Labda we have to do it as a community, Tanzania ya community, tuendeleze data set ya Kiswahili, tuangalie how tunavyoshirikiana na BAKITA, lakini iwe close. Ndio. Kampuni za Vodacom, TTCL wakitaka kutumia huko Airtel, wanakuja Tanzania Air Community hapa free. Wanapewa, lakini it's like na sisi tutajua wale stakeholders waliohusika, tutacontribute huko nani. Kwa hiyo there's so much we can do as a Tanzania Air Community, lakini tukiangalia experiences za wenzetu kwamba kwenda open source, wale wanao download na benefit sio actually wale walio contribute hiyo language, ni hizi companies na nini. Kwa hiyo there's a lot we can do. Easy debate, yani they have to go through our AI community. Now, there's so much that we can do together.
Yeah.
Na especially to protect zile nani, to protect zile rights. Yeah. It's very tough.
Thank you so much, Dr. Dina. So I think time is over actually for the session of RAG and intelligent agent, but the session is going to be more practical on Saturday, so I was trying to highlight some key things. So for online, Madam Erika, thank you so much with your team. We really appreciate. I see Ipiana here. So Ipiana was my teammate actually on the project I talked about, the ITU TNML challenge. Thank you so much for being here, brother. We appreciate. And I think tomorrow we are going to make the experience much better compared to today. We appreciate and thank you so much. See you tomorrow.
Thank you.
Yeah.
But the sound at the end was good. I don't know what's up in the session.
Yes.
The sound right now, the sound is good.
I say very sorry. Sijua nini kinatokea. Yeah, asante sana Madam Pole pia.
You're very far from the mic, Bana.
No?
Try.
Thank you so much, madam.
Okay, thank you.
See
you tomorrow.
Okay, thank you so much. Yeah.
Okay.